And we thank you for the opportunity to be able to team up with you for this advisory council meeting. The presentations, the last 3 days of the sessions have been fascinating, and my Zoom meeting just glitched out on me there. And we look forward to today's presentations, and we know that they'll be just as fascinating, just as interesting. So keep up the good work. It's a privilege to be teamed with WERI and see what's going on in Guam and CNMI and around the rest of Micronesia.
Great. Thanks, Aaron. If I seem a little discombobulated this morning, when I walked in, they were testing our security system, and alarms and bells and whistles were going off all over the place for the last 20 minutes. There's nothing like having a nice quiet time to go over your notes and get ready before a major. So we're operating in a real-time environment here. I'd like to begin. Let's see, Michelle, can you put up my presentation? Thank you. As I usually do, by sharing just a few words of explanation of who we are here at WERI and what we do. So first, next slide. I'd like to, as I usually do, brag about the folks here at WERI for a couple of minutes. Next slide. Many of you have seen these slides before, so I'll just kind of summarize. I've got the best administrative team that you can imagine. They're managing 40 different accounts and $2 million worth of accounts, and they do it flawlessly. Keep me out of trouble and keep the organization going. I just do what they tell me to do. We've got a research staff that runs our water quality lab. I'll say a little bit more about them in a minute, but their water quality lab is one of the crown jewels at UOG. And our research faculty covers the whole water cycle, from rainwater to wastewater and everything in between. And that's one of the key management principles by which we operate here at WERI. Next slide. Our water quality laboratory supports our research, as well as collaborative research with other organizations at UOG and around the island, and supports the needs of the community, the business community. It keeps the money that they have to spend on laboratory work circulating here on the island rather than going off to Hawaii or California, and saves thousands of dollars for materials that would otherwise sometimes cost tens of thousands of dollars for special handling to go to California. We keep that right here, and they do a great job. We're going to be expanding the lab when we hopefully get a new building here in the next couple of years. Next slide. And I can't give enough credit to our talented graduate students who are the research assistants on our projects. Graduate students are the frontline troops of science. And we've got the best that you can imagine, both the local talent as well as students that hear about us and come from the mainland and around the world. And it just keeps on going, getting better. Next slide. So just a few words on our mission. Next slide. In 25 words, our mission is trustworthy and timely research, instruction, and advice to support scientifically informed development and effective management of the freshwater resources of Guam, CNMI, and FSM. Next slide. So I'd like to say a bit about what we're not. We're not activists. We're environmental scientists, not environmentalists. We're not politically correct. We follow the data, not the funding sources. We're not yes men or women. We tell our clients and partners both the bad and the good news, and we're not shy. We tell the truth, especially when it's not welcome, but when it's needed. And we're not prima donnas, we're team players and public servants. In environmental decision making, I'd like to say just a couple of words about items. Uh, uh, I'm sorry, let me go on the next slide. Get ahead of myself here. Our core values are reliable and honest science, consultative decision making, and across the board teamwork. Sincere partnerships with public and professional agencies, earnest service to the community and university, and superb instruction and conscientious mentoring. In decision making, especially when it's controversial, and it often is in environmental work, our job is to provide everyone on both sides of the issue, and sometimes there's even more than two sides, with reliable data and the best interpretations we can muster with the resources we have. And that includes explaining the limitations of the data, as well as the limitations of the resources we're working with. In environmental work, decisions usually have to be made with less than perfect knowledge. And decision makers and advocates on both sides of the issue often turn to the scientists because in our modern culture, we're afforded great authority, more than we deserve. But I like to quote the famous physicist Richard Feynman, who said that any scientist speaking outside his or her field of expertise is just as dumb as the next guy. But we're on the team to provide the advice from our fields of expertise to policymakers, executive decision makers, managers, regulators, and citizens, and give them accurate and reliable knowledge on which they can base decisions. We don't speak with authority on any aspects outside of our own fields of expertise, and we make it our role to provide honest and reliable advice and participate in the decision-making process and as members of the team. So I'll have more to say on that and as we go. Next slide. I'd like to wrap up by acknowledging the success of our students. We're especially proud of the record that they've established. Next slide. Including having won some national awards, local awards, and the university awards for outstanding theses. You're going to hear more from one of them in a few minutes here. Kaylin Bautista is going to be presenting our State of the Aquifer report. She won the President's Award for the outstanding thesis of 2017 for work that she did on groundwater percolation in the Northern Guam Lens Aquifer. And speaking of the university president, it's my pleasure to welcome Dr. Price.
Thank you, John, very much, and congratulations. Thank you. Thank you. Thanks to everybody for putting this on. So the whole WERI team and to the Global Learning and Engagement team who've made this possible. Thanks to everybody for showing up for this and for participating. Just a few words from me of thanks and acknowledgement that WERI is doing such an amazing job and is such a resource for the university community, the whole of Guam, and really the whole of Micronesia. You've heard that our WERI is one of 56 such institutes across the United States. And every year they designate the top 12. So they don't rank the whole group, but the top 12 as a group are acknowledged. And our WERI is one of those top 12. So that's a really remarkable achievement. And then ours is also unusual for extending to the CNMI and to the FSM. And so that makes us also distinctive, and I think that's really important. And I love to emphasize how much WERI sort of touches on all the things that UOG is good at. So the very high quality education, the very high quality science, the research, the partnerships with the community, with other agencies around Guam, the government of Guam, even down to sponsoring the Water Kids program and doing fundraising for scholarships for the water kids, for all kinds of activities, for giving people opportunities, for showing them what's possible for careers. All that sort of thing has been really terrific. WERI is a great partner in all the things that we're pushing for in Guam and the region, including the Guam Green Growth and the everything to do with environmental sustainability, for dealing with the pandemic and the economic impact of that and how we come out of it. So WERI really has been so important in so many ways. The water quality lab has been important. And I think it's worth noting that Guam is one of the relatively few places in the world where you can drink the tap water. So the quality of water is a real marker of kind of first world status. You look at a map, you know, our region, this whole Asia Pacific region, there are lots and lots of places where you can't drink the water. So WERI is important to maintaining that real distinction that we have of high quality water and really a high quality approach to all of these scientific problems. So congratulations to the WERI team. Thanks very much to the advisory council, all the partners involved in this multi-day effort and in the effort throughout the year. So Situt Masi to all of you, and look forward to the rest of the program.
Thank you, President. We'll do our best to live up to that high praise. Thank you.
Yeah. John, I'm going to congratulate you. We are proud of you.
Well, thanks,
Very
Ram.
good. Excellent.
We build on a great legacy of past leadership and past scientific strength. So yeah, thanks to you and Dr. Heights, Dr. Denton. I can name everybody else that came before me, but it's been a team effort and it continues. Speaking of team efforts, I'd like to, before I introduce the next speaker, just acknowledge the partners and professional collaborators from around the island. We're fortunate to have solid working relationships and really productive relationships with the other water resources agencies here. GWA, Guam EPA, NEFEC, MAR, and our own on the campus here, School of Engineering and Professional Societies, AWWA and SAMI. It's really gratifying and rewarding to work in the kind of environment that we work in, interdisciplinary, and actually put the science that we do to work solving problems. I'm pleased to have Captain Libertor join us. We've had a great relationship with the Naval Engineering Facilities Command for many years, and it just keeps getting better. And the members of our legislature, agency heads that are here, again, thank you for your participation. So I'll turn the controls back over to Amanda here to introduce Kaylin, who is, by the way, has been recently hired by USGS to run the data collection program here from Guam in conjunction with their people that come out quarterly. And we're hiring her starting tomorrow. She's going to have two part-time jobs that are complementary to coordinate the expansion and rehabilitation of the data collection system that we have on the island, which you heard about last week. So I'm taking part of Kaylin's time, so I better get off the stage here and give the controls back to Amanda so that she can get underway. But Kaylin's one of our stars, and so she helped prepare this report on the state of the aquifer, and I asked her to deliver the report this morning. So you're going to hear from one of our superstars. I'll turn it back over to
Thank
Amanda.
you so much, Dr. Jensen. Thank you. Before we move on, I start the presentation for Ms. Kaylin. I just do want to acknowledge, in line with University of Guam protocol, I want to acknowledge the presence of one of our UOG Board of Regents, Mr. Pete Diaz. as well as our Vice Provost for Research and Sponsor Programs, Dr. Rachel Young Guerrero. We also would like to acknowledge Senator Regine Bissell-Lee and Senator Sabina Perez, who are joining us today, as well as Mr. Dean Tim Conto, who is the Dean of the College of Micronesia FSM campus. So thank you again all for joining us. With that said, we'll go ahead and hand the floor over to Ms. Kaylin Bautista for her presentation on the 2020 State of the Aquifer Report.
Hello, good morning, everyone. So thank you, Amanda and Dr. Jensen. First off, this report is one of the newest productions from WERI, and what's really great about it is it's the first of its kind. And from the State of the Aquifer report, if you are looking for basically an executive summary that you can use if you're a manager, a policymaker, educator, this is kind of like a summation of a lot of research that WERI has gone through in the 70 plus years it's been in existence. And so the data presented in this report is scientific. So we do want to put the disclaimer that it is subject to change from time to time. And once we collect new and better data, of course, we'll be able to have better analysis to produce for our local community that can be useful in different aspects. So if you would like to see a digital version, it is included in your advisory council packet, but also the report can be downloaded at the WERI and GUAM Hydrologic Survey websites. Next slide, please. So highlighted in the report, you will find topics such as sustainable yields and production rates. We are going to talk about the salinity research results that we've come up with so far. Briefly, we're going to show a little bit of what we've been doing in terms of exploring for optimal wells locations. Briefly, we'll go over the nitrate research that has been done, and also the PFOS or PFOS research. Next slide, please. So for sustainable yields and production rates, currently the average daily recharge for the NGLA is 238 million gallons per day. And over the 6 basins, as you can see on the NGLA map, we have them divided by hard and soft boundaries. But this map is 15 years old. So from that, 238 million gallons, annually it's about 100 inches of rainfall. The total groundwater production does range between 35 to 40 million gallons per day. And that's only 15 to 17% of that average recharge. The table on the top right, labeled current production, it displays what the total production was in 2019 and also the first quarter of 2020. So we have multiple producers from GWA and the Department of Defense. And we would like to acknowledge the Guam Waterworks Authority and NAFAG-MOR for their teamwork and awesome data sharing. Because with this data, WERI can analyze and give reports to GWA, to the military, and to all of WERI constituents on what we have learned. And this also aids in supplying information to big questions such as what are the sustainable yields and where are we currently in terms of NGLA production. And also further on, we're going to talk about another big question, which is salinity. And so from a recent modeling study done last year by Daniel Superalis and some of the WERI faculty, what has been calculated is that 70 to 80 million gallons per day is the limits of the best possible case configuration. And what that means is that's putting all the production wells in the parabasal zone and pumping it at different rates. So the table at the bottom displays the quality of water between those two limits. So for 70 million gallons per day, the water quality is being pushed to 150 parts per million chloride. And of the total production, which is 41 million gallons per day, that's only 59% of this sustainable yield limit. Going to the next one at 80 million gallons per day, the water quality is pushed even further to 250 parts per million chloride. And again, current production is less, it's 51%. Next slide, please. So the second big question is salinity. And here is a table and some figures that have been highly asked about in terms of this question. So far for WERI studies, by looking at salinity patterns and trends of the NGLA, what we can see is that in wells varying by location, depth, pump rate, and also whether it's seasonal and interannual changes in rainfall and sea level, we can produce these types of figures and graphs. And that's all with the great help of GWA and the Department of Defense. And so moving on from that, currently the US EPA standard for salinity is 250 parts per million, and that's equivalent to 1.3% seawater. The NGLS study that was done back in the 80s had a recommendation though of a maximum of 150 parts per million, or 0.8% seawater, as a local engineering design standard for the wells in the basal zone. So the table at the top displays the chloride production by basin, and it also breaks down by basin the number of active wells, the production rate or the total pump rate, and the production weighted average chloride for GWA wells just up to May 2019. So out of the 94 active wells at that time, the pump rate was 35 million gallons per day, and the average chloride was 91 parts per million. So chloride average is displayed again for each basin, and then you can see which ones are shifting the total average value higher or lower in terms of chloride. And this has changed quarterly and even yearly. So I don't want to steal the thunder from the other presenters because they will expand on this. The three figures on the bottom, starting from left to right, this is from the 2019 salinity model, and this was done for 130 wells of the NGLA. So the first one on the far left shows the actual chloride of the actual production well configuration. So these are wells in the parabasal, supra, and basal zone. So the current placement, and that is the locations and where the 41 million gallons per day came out of in 2019. So the well colors of this system or of this configuration follow the legend on the right, and you can see as you move to the middle and the far right, the legend on the left. And if you move to the figures in the middle and the right, you can see the shift as production increases to those two limits of 70 million gallons per day scenario and 80 million gallons per day scenario. So they're shifting from mostly black and green, which is 70 or 150 milligrams per liter chloride, to higher salinity. Some wells even maxing the US EPA limit and a few of them going further, to over 500. So again, the last two figures are showing an ideal configuration in which all the wells would be placed in the parabasal zone. The first one is the actual configuration, just to remind everyone on that. So next slide, please. So the reason why that study was done to switch and put all 130 wells, or probably more, into the parabasal zone is because the parabasal zone has advantages. The wells can be set deeper and then they can be pumped harder than the basal zone. And that's because the parabasal zone, while it's only 5% of the aquifer, it does capture all the water descending from the superbasal zone, and that is 25%. And the superbasal zone is invulnerable to salt water because the water is coming from the volcanic regions. It doesn't have any saltwater interaction underneath. Next slide, please. So the next question that WERI is helping to answer along with US EPA, GWA, and the Navy is, what are the nitrate research results? And a lot of the nitrate studies was done by Dr. Denton, Dr. Bana, and the late Dr. Rouse. And so far what WERI has informed the community is that So our studies show that the organic bound nitrogen in sewage and other organic places that nitrate comes from is being converted to the nitrate form before it even reaches the groundwater. And so this indicates that the Vado zone is biologically active, and that the thought is that most of the activity happens in the first 20 to 60 feet of the limestone layer. So that I have some pictures showing epicars that have these deep pockets. And that's the bottom picture shows Smithbridge Quarry, and then we have the figure, the schematic of how deep some of these, this zone can get. And so, again, recent studies show that no short-term daily or weekly variations in nitrate levels are occurring. We do have historical trend mapping that you'll hear of a little later today, and there's some really great analyses being done based on some of the research, the data that's been shared. So we're really grateful for that collaboration again. Next slide, please. So the last topic that's in the report does talk about the PFOS research results. And it's just a brief summary in the report and even in this presentation, because I don't want to steal the thunder from anyone else, but basically the short version for what we have so far is that of 22 sites that were sampled for PFOS, there have been identified 4 potential contamination sites. And Mallory Duenas is doing a study for her thesis on this, and she's going to also discuss later on more of the methods and additional information on that. So please stay tuned to hear more. Next slide, please. I do want to thank everyone for listening. Again, the State of the Aquifer report is a type of executive summary, so it's not meant to go very in-depth. We do have the individual presentations today and technical reports and publications that if you want to learn more or get more details, you can definitely find them on the WERI database under publications, reports, or even the GUAM Hydrologic Survey under the sort and search. This is what our report looks like for this year, and we look forward to more data coming in, more great collaboration, and be able to analyze and define a bit more the answers to those questions of production rate, sustainable yields, salinity, nitrate, and any contaminants such as PFOS. I thank you for your time, and I do hope you enjoy the rest of the presentations. So thank you very much.
Thank you, Kaylin. I'd like to reiterate real quickly what one of the points that Kaylin made, that one of the advantages of this modern technology, putting stuff online, is that you can update it frequently. And one of the disadvantages of having it online is that it gets updated frequently. So it's a moving target. We're doing our best to keep it up to date as new data comes in. But don't be surprised if when you look at it 6 months later, it's a little bit different than it was at the time you last looked at it. Thanks again, Kaylin. I'll turn the controls back over to Amanda.
Thanks so much, Dr. Desmond. Thank you so much, Kaylin, on that great State of the Aquifer report. At this time, I'm now going to hand it over to our next presenter to present on nitrate analysis update.
Good day and good morning. My name is Resolyn Blacklock, and I am an undergraduate research assistant at WERI under the mentorship of Dr. Nathan Habana. My presentation is an update on the nitrogen trends of wells extracting from the northern Guam lens aquifer. As a brief background, US EPA notes that known contributors to groundwater nitrates include elevated fertilizer use, agricultural activity, and improper wastewater management through septic tank leach or sewer leaks. When I presented at GAP last year, I was just in the beginning and planning phase of this project, and today I will fill you in on my progress since then. Next slide, please. So this study goes off of the last nitrate nitrogen analysis conducted almost 20 years ago by Ms. Maureen McDonald. In her 2002 technical report, she had found that out of 147 wells observed, 39 had increasing nitrate trends, 9 had decreasing trends, and 99 were insignificant. Using the same method McDonald used on the additional data gathered from Guam Waterworks Authority since the 2000s, the updated result, which is highlighted in yellow, show that 84 wells now have increasing trends, 7 decreasing, and 55 insignificant. Comparing these results show a large surge in the number of wells with increasing trends. Next slide, please. So 2 common statistics requested of us during this study were the average and maximum concentration. While looking at both these statistics provide a simple overview of the state of each well, there are some limitations to using both as representation of the whole data set. Let's examine the average first on the left. These 2 wells show opposite trends and outlooks, with the top graph F1 increasing to almost 5 ppm, while the bottom graph A25 is decreasing to about 3 ppm. Despite the decreasing trend of A25 on the bottom, this well actually has a higher average at 3.5 ppm compared to the F18 average of 3.2 ppm. Now, when observing maximums on the right side, this table shows the highest concentrations recorded and the dates of those samples. The third well on this list is well Y3, whose graph is shown below. The 5.37 ppm maximum concentration was recorded way back in 1987, which appears out of the typical trend. So although Y3 has one of the highest recorded maximum concentrations, the well's trend is actually insignificant and level at about 3 ppm. As depicted in these examples, looking at singular statistics may offer misrepresentations of the current state of each well. Constructing these individual well graphs, which we did for all 147 wells, provides a more holistic visualization of trends, clusters, or significant changes in nitrate concentration. Next slide, please. We use the linear regression equations as shown in the previous slides to provide a better visual representation of the testing and concentration history for each well. Another goal of ours was to be able to predict future concentrations, assuming that the trends would follow the linear model. Using the regression equation, we extrapolated to what the future concentrations of nitrates would be in the next 10 and 20 years. The red highlights in the table indicate predictions exceeding 10 ppm, which is the maximum contaminant level set by US EPA. While the yellow highlights is half the limit at 5 ppm, which calls for investigation and intervention. However, there are also some limitations to focusing on the linear model, which include a low number of samples for several graphs. Some wells had data less than 5 samples, which does not provide a strong confidence around the prediction. Another limitation is an unreliable spread of data, which we will discuss in a later slide. We are also working on providing maps, such as the one on the right, to visualize clusters or areas of concern. Next slide, please. So this slide investigates the accuracy of the linear regression model by comparing the predictions to actual recorded concentration. This table lists the top 20 wells with the highest, most recent concentrations. The column abbreviated CONC, or concentration, shows the recorded concentration on the latest sampling date, while the prediction column to the right of it shows the model's output given the same day. As you can see, some of the concentrations are pretty close or spot on, while others have a larger error. The error was calculated on the last column of this table, and a positive error indicates underestimation, while negative error shows overestimation by the model. The average error just from this data set came out to be negative 10.5%, indicating a slight overestimation overall. Next slide, please. As discussed previously, we need to take into account the spread of the data. This slide shows 4 scenarios we encountered. For each graph, the blue dots and lines indicate the old data from the previous study in 2002, while the black colors show the new trend indicating the updated data. The first case on the top left shows an ideal case where the trends from the past line up pretty well with the addition of the new data. In contrast, the HGC2 graph on the top right shows the case of opposite significant trends, where it had been significantly decreasing at first, but now is significantly increasing. F13 on the bottom left also shows a more positive shift in trend, being significantly increasing in the beginning, but now exhibiting an insignificant trend. And the last graph on the bottom right, MGC4, shows the case of no recent data. And as the other cases show, there could have been a shift in trend since then, or even follow the same one. Next slide, please. So when observing the spread of the data, we had also noticed instances of a shift in trends, both good and bad. This prompted us to look at specific time intervals. In the case of EX11, the blue data points and lines show data before the 2000s, while the green points and lines show only data after the 2000s. The black line in the middle showed the trend using all of the data points. So the blue line looks as if the well is exhibiting a high increase in nitrates concentration. In comparison, the green line appears to be insignificant and level at about 4.5 ppm. There appears to be a shift transitioning into the 2000s that positively altered the look and projection of the trend. In this case, it appears that the more recent data after 2000 is a better representation of the future outlook rather than looking at the whole data set. As a note, 20 of the 84 significantly increasing wells depict a similar trend to EX11. But despite this, 64 wells still show that after 34 years, it is still significantly increasing. Next slide, please. So I've discussed the different avenues of analysis as well as the limitations that each face. To account for this, we decided to rank the wells using a priority ranking of several combination of conditions. That way, a number of conditions are taken into account rather than just one. So far, we have been looking at the R7 ranking, which is outlined in purple, which gives priority to the significance of the trend, followed by the linear trend predictions, the spread, which is determined through the annual sampling frequency, and lastly, the error analysis. This ranking can change drastically depending on the order and priority of the condition selected. We are still trying to determine which order would be best representative of all the factors that are concerning. And again, we are also planning to map this in order to show any clusters in the map. And last slide. So lastly, we plan to construct an updated NGLA map with the concerning wells overlaid with relevant information, including roads, sewer lines, septic tank leaching fields, and much more. This will help to provide a visual analysis of adjacent structures. So far, applications from this project include the use of our results for legislation on sewer expansion and septic tank regulation. Furthermore, we plan to examine development density and proximity at the wellhead protection zones. Finally, further research in this field involves being able to model the groundwater flow of nitrate contaminants. With this, I'll conclude my presentation, and my email is listed below if anyone would like to reach out for questions or requests. Sidu Masi, and thank you.
Thank you so much for that great presentation on our nitrate analysis update. Up next, we'll go ahead and go to the next presentation, which is titled Potentially Impacted PFAS Sites in GUAM, presented by Ms. Mallory Duenas.
Hi, thank you. I'd like to confirm if my audio is coming off okay.
Your audio is great, Mallory.
Perfect, thank you. Hi, my name is Mallory Duenas, and I will be presenting on behalf of Dr. Barry Kim, who is my advisor. And I'll be presenting on the potentially impacted PFAS sites in Guam. PFAS are man-made perfluorinated compounds. Two compounds, PFOS and P4, are no longer produced in the US, but they can still be found in products coming from other countries. The unique amphiphilic properties they possess allow them to be both persistent and mobile in the environment. Past studies have showed PFAS to be persistent and bioaccumulating agents in humans. Therefore, 6 common detected compounds are listed in the UCMR3 and are monitored by regulatory bodies. Results from a US EPA study found 6 of Guam's groundwater wells were contaminated with PFAS. In this presentation, I will focus on Pagania wells A23 and A25 as their concentrations exceeded US EPA's health advisory limit of 70 nanograms per liter. Sorry, it's kind of slow. Okay. Potential contamination sources near A23 and A25 are suspected to be contributing to the elevated concentration in these wells. Hydrogeological and literature research led to the selection of the following candidate sites that were subjected to or impacted by a known source of PFAS. Potential use of aqueous firefighting foams may have occurred at an airplane crash site incident at Nimitz Hill. Contaminated runoff during rainfall events will collect in stormwater drainages or ponding basins. A pump station along Chout River released millions of gallons of wastewater into the river until it was upgraded in 2006. Surface water flow from Chout River could transport the discharged wastewater to Agania Swamp, which was also an illegal dump site in the past. If my audio goes out, please let me know.
Hi, Mallory. Sorry to cut in really quick. Let's just, we're just going to do a quick audio test. It seems that your audio is cutting in and out.
It is? Can you hear me better if I'm this close?
Yeah, so if we can just have you closer to the microphone to ensure the quality of the audio for today's meeting. Thank you so much.
Okay. During our preliminary study, we collected 22 soil sediments, 3 surface water, and 2 groundwater samples. Multiple samples were obtained from Chout River as waste had overflown from a sewage cover next to the river, Bergania Swamp. Samples were taken from stormwater drainages, as well as 3 sections of the Hagåtña River that runs through the swamp. Samples were shipped to University of Rhode Island for PFAS analysis. Out of 34 PFAS, 19 of them were detected above 0.01 microgram per kilogram. Of the 6 UCMR3 detected, PFNA had the highest concentration of 14.4 microgram per kilogram in sample 4. PFOA, PFPS, PFOS, and PFHXS were also detected in sample 4 from Chout River. Other compounds detected in 95% of all the samples were Gen X or HFPO and highest concentration of GenX was detected at 15.6 microgram per liter, microgram per kilogram, in sample 2, while 6,2-FTS was 16.1 microgram per kilogram in sample 6. Uphill from the wells, Ponding Basin 1, sample 16, had the second highest total PFAS detection. PFAS and PFH excess were dominant in Basin 1 with 4.75 and 5.55 microgram per kilogram, respectively. GenX is a less persistent and bioaccumulating replacement for PFOA. FTS compounds are potential carboxylate or PFCA precursors that can degrade to PFOA. And 6,2-FTS is associated with aqueous firefighting foams and is one of the replacements for PFAS.
Hi, Ms. Mallory. Thank you so much for the presentation. While we're fixing the audio issues, we're going to go ahead and move forward to the next presentation so we can rectify these issues. On a side note, we will actually be sending out Ms. Mallory's presentation recorded version with the audio issue addressed for viewing after this. We apologize for the technical difficulties today, and thank you so much, Ms. Mallory, for this great presentation. As I mentioned, I know that we had a couple of technical issues, so after this meeting, we will send out a recording of Ms. Mallory's presentation as well as clear audio for all of you to view. But once again, thank you so much, Ms. Mallory, on that presentation for potentially impacted PFAS sites in Guam. Up next, we will go ahead and move on to Ms. Adrian Amalo.
Hi, good morning, everyone. I'm Ajalyn Omalao, and I'm a graduate research assistant working with Dr. Yuming Wen and Dr. John Jensen, to establish a geospatial temporal analysis of chloride concentrations in the northern Guam Lens aquifer. Next slide, please. So about 80% of the water we drink comes from the northern Guam Lens aquifer. Previous technical reports by WERI demonstrate that chloride concentrations have been on the rise since the 1970s, and factors that affect salt concentrations in the aquifer include precipitation, evaporation, and recharge. The highly porous character of the aquifer makes it more at risk for chloride contamination through saltwater intrusion. And chloride can enter the aquifer from human activity, like from runoff, septic systems, fertilizers, chemical spills, and so on. The maximum contaminant level of chloride in groundwater suggested by Guam EPA is 150 grams per liter, and by US EPA is 250 grams per liter. Chloride concentrations at 250 grams per liter can make the water taste salty, and further increasing concentrations can lead to high blood pressure and diseases of the heart, liver, and kidneys. High salt content in water can also cause plumbing degradation, and these numbers are not heavily enforced by local and federal systems, as chloride is classified as a nuisance substance, not a health concern, and as the negative effects of chloride depend on the cation it is bound to. Next slide, please. The purpose of this research is to find salinity trends in the Finnegodson and Jigotuman area, because these areas have been subject to a lot of urbanization, with the military buildup in Finnegodson and the Jigotuman area being a heavy residential and tourist area. Another objective is to compare salinity in the Finnegodson and Jigotuman basins to the other basins and establish a GIS model for trend and pattern analysis for chloride contamination in the northern Guam Lens aquifer. Samard's technical report by WERI showed salinity from 1973 to 2010, and this project aims to provide patterns and trends from 1973 to present, potentially updating the 2010 report. And These findings can also be added to the Northern Guamlands Aquifer database made by Bendixson in 2013. And further, these resources, sorry, these results can be used to make suggestions for aquifer management in future studies. Next slide, please. I apologize if the figure is a little hard to see, but this is the study area. Subbasin boundaries and fall locations are available online through the Guam Hydrologic Survey website. The pink area is the Finnegodson subbasin and the green is the Jigo-Tumon basin. And the different points indicate well locations and the colors indicate the operating agencies for each of the wells. And next slide, please. So this is a preview of the chloride in production data that I've got from GWA and organized by WERI's Thomas Aguilo. The data starts as early as January 1973 and it is as recent as February 2020. Next slide, please. Next slide, please. So I plan to perform statistical analysis with the chloride and production data and with climatic data sets. The climate data like rainfall and land cover were retrieved from online databases, rainfall from NOAA and land cover from NOAA, US Forestry, and the National Park Service. The common statistical tests that I saw from previous reports that I also aim to conduct are correlation regression, multivariate analysis, principal components, and any other tests that I might find useful in the future. Next slide. And for GIS, the most common methods that I've found are that I also will try to do are ordinary creaking and Thiessen polygon. I also plan to use GIS modeling like Model Builder and other methods like geostatistical analysis. And next slide. So I don't have any results yet, but this research focuses on data from early 1970s to the recently available data and evaluates the patterns and trends of salinity from an extended period in the study areas. Based on an analysis of chloride data from 1996 to 2009, there are salinity problems in Guam, and as concluded in Samard's paper, Salinity in the Northern Guamlands Aquifer, there was an increased trend in salinity from 1973 to 2010. And I also predict to see an increase in salinity from 1973 to the present and hope to find patterns, particularly in the Finnegodson and Jigo-Tumon basins. And after finding these trends and patterns, we can see how it impacts our current water quality and suggest how to manage water sources and supplies in the future. And next slide, please. And these are my references. And next slide. And I would like to acknowledge the US Geological Survey and Guam Hydrological Survey for providing the funding for this research. And thank you. Does anyone have any comments? Thank you.
Thank you so much for that great presentation, Ms. Agelin. Before we move on to our next presenter, I'm going to just go ahead and share a quick video with a quick fact about WERI while we transition. And up next, with her presentation on establishing groundwater protection zones, Ms. Kaylee J. Chargala.
Hello? Is my audio
You're all
okay?
set.
Okay, thank you. Buenas and half a day, everyone. My name is Kate J. Chargloff, and I'm a research assistant at WERI. I'm working with Dr. John Jensen and Dr. Yuming Wen, along with the help from Mr. Brian Bearden from GUAM EPA. And my project is on establishing groundwater protection zones in the Northern Guam Lens Aquifer. Next slide, please. So the issues I'm trying to address is one of them is Guam's need for a useful aquifer protection strategy, along with the island's need for updated guidelines and regulations that regard the management and delineation of groundwater protection zone in Northern Guam. Next slide, please. So in this project, I will be using GIS to create a map that will be comprised of these components that are affecting the aquifer, including but not limited to sewage, septic system use, well locations and well usage, along with others, including human activity, development, land use, chemical contamination like chlorides and nitrates, and impervious surfaces. So I'll just be trying to make a big map that is going to have all of these components to get a better look at the groundwater protection zone. More so, I'll be looking at a lot of our legal documents, including the Guam Code Annotated, Guam Administrative Regulations, and a lot of documents from Guam EPA, and just overall looking through different laws in our bulk of Guam compliance laws. I'm sorry, I think there was a slide that was skipped. Can you go back one? Okay, yeah. Next. Okay, that one. So my objectives in this project are to look at the factors that affect the aquifer and groundwater in that area, including contamination, well and sewage use in that area, in those areas, and then looking at what legal policies, bills, laws, and statutes we have on Guam that are affecting the aquifer and the groundwater protection zone. And also looking at current methods that we have in the law that help with the delineation of the groundwater protection zone. Okay, next slide, please. Next slide. So on the left, this is just a figure showing all of the, I guess you could say, like the big people and organizations involved in groundwater protection zones. And this includes local government, including our environmental authority, health authorities, planning authorities, agriculture, public water use, which includes GWA and the people's use of wells and septic tanks. And of course, along with the federal government, them being a very big component in Guam's aquifer. And on the right, this figure is showing just a sort of how a protection zone can be delineated in regard to groundwater abstraction and also the placement of a groundwater well. Next slide, please. So as mentioned before, I will be looking at the GCA and the GAR, which are the GUAM code annotated and the GUAM administrative regulations. And some of the big documents I'm looking at include the Water Resources Conservation Act, Water Pollution Control Act, Water Quality Standards, and Water Resource Development and Operating Regulations. Next slide, please. So my expected results after looking at all these documents, all these laws, bills and statutes, I'm hoping to have a method that I can present to establish an updated groundwater protection zone in the aquifer, and to present this recommendation or recommendations to improve the management and protection of the overall aquifer and the groundwater protection zone. And then with the use of GIS, I expect to update the map that we currently have of the groundwater protection zone and the aquifer, composed, which is will be composed of the environmental factors that I mentioned earlier. Next slide, please. These are my references. Next slide, please. And this research is funded by the USGS program, GHS, Guam Hydrologic Survey. Thank you.
Thank you so much, Ms. Tardowa, for that great presentation. As a reminder, we are going to have a discussion portion later on in the meeting. So if you have any questions or comments, we encourage you to share it in the chat, and we'll definitely come back to that at the end of the meeting. Up next, we have a presentation on the hydrologic analysis and modeling, hydrological features and analysis in the Finnegavan area by Dr. Yiming Wen. We'll just play a short introduction. And Dr. Wen, the floor is yours.
Good morning, everyone. This is Yiming Wen from WERI. And my topic focuses on hydrological features and also analysis of some features in the start area and Finnegavan area. And next one, please. And the topic focuses on give some ideas about projects objectives, and then focus on collection of data and the processing of data for start area, and then focus analysis of some features on the all and hydrological features in the start area, and they give you some brief conclusions and discussions. And next one, please. Next one, please. Thank you. And the project focuses on collection of hydrological features in the Finnegavan area, and the analysis of hydrological features in the start area, and then an evaluation of impacts of hydrological features on groundwater quality. And for my case, I most focus on chlorides and concentrations in the start area. The next one, please. For hydrologic features include a bunch of, and I'll give you some brief information next slide. And then, and the data and what quality data, not just chloride, also include other contaminants from GWA, and all the back to historical data back to early 1970s and all the current data available from GWA, and the well locations and other features related to hydrological features. The next one, please. And this slide shows the location of Guam. You know, Guam is kind of close to some major Asia countries and also Oceania country. It's take about 4 hours to by air to South Korea, Japan, China, and Philippines and Australia. And look at the Guam is kind of shape of the print. And my start area focuses on Finagajin area. In the far right one. And next one, please. So this slide shows kind of geological features. And for Guam, you look at the geological features, and the northern Guam is kind of composed of limestones, and the southernmost kind of composed volcanic deposits. And in the past years, many people, sent emails to us for and information about rivers or watersheds in northern Guam. I just tell them that we don't have a surface kind of rivers in the northern Guam because of this kind of features, geological features. And northern Guam is the most composed of limestone, and when water comes down, then it will penetrate to the groundwater. So next one, please. Now, for geological features data, we collect a bunch of data. One is a DM from USGS, and that one is in the resolution about 30 meters, 30 by 30 meters per pixel. And we also have LiDAR data for 2007, and also another one is in 2012 and to 2013 from NOAA. Now for LiDAR, we can compare with DM from USGS, so we can get a much higher resolution information. And when we use the LiDAR data to get a kind of deprived information, and such as slope length, and flow directions, or surface watershed, even though we don't have surface streams or rivers in northern Guam, but the topographic obtained from LiDAR data. Also, we can still use such information to look at recharge rate and to aquifer, because the landscape may be affect and the recharge rate and from rain and precipitation. And water quality data from GWA, as I said before, and protection data, and also from GWA. And we can look at water quality data and protection data, and a bunch of researchers or students are also from WERI. They have conducted some research on the relationship between water quality and the well production in the northern Guam. And well locations, and for well locations, and also we look at the different kind of types of wells, and private or public, and different kind of usage and for different wells. And climate data, and we collected a bunch of, including precipitation, temperature, for temperature including surface air temperature and seawater surface temperature. And other include the tidal information, sea level rise information from NOAA. And for precipitations, we can get minute-based or hour-based, data-based, month-based, annual-based data. And also look at land cover information is kind of related to human-induced activities. And we have data from US and FS Forest Service, NOAA CCAP. For NOAA CCAP, we have get 2005, 2011. And also I have my own land cover data from Landsat images back to 1973. This is 2006 and not 2009. And you know, if you look at the land cover or human activities, because we have a bunch of built-up activities, I think the activities will affect not just what quantity and also what quality. So we will look at how build up or other human activities and affect what quantity and what quality in the Northern Guam. And next one, please. So this shows from a previous project, shows the land cover information in 1973 and also 2006. Click, please. And click next, please. Next one, please. So next few slides just give you analysis of some hydrological features. Next one, please. So this one shows geological features, and they look at you know, in the middle you can see the mesh area, and that is for peribasal and zone, and the right is for suprabasal, and the left is for basal zones. Next one, please. And that shows land use zoning information. And if you look at you know, the relationship between the peribasal, basal, and suprabasal, and well locations and other geological features, so we can figure out what's the kind of relationship between them. And next one, please. You look at this is kind of chloride information is its interval is 10 years, and you look at the trend. The general trend is kind of chloride increasing and over the years. And next one, please. This shows for well F10 and the relationship between chloride levels and the production, and the general trend is kind of the production increase and chloride level increase a little bit too. And next one, please. This one just shows, you know, look at in the middle, right? In the middle, and the production is almost stable, but the chloride levels increased. And the left to right is kind of production down and chloride level down, and production up, chloride up, and the relationship kind of mixed. And next one, please. So this slide should give you some kind of you know, relationship between chloride levels and some other features. Other features. The black ones shows the location of sinkholes, and the blue slash line the right is for suprabasal area, and the mesh light green and mesh line area is for peribasal, and the yellow slash lines for basal area. You can see, and most purple wells with chloride located in peribasal. Just one located in maybe all, because for F12, it looks like located in peribasal. I think when I zoom in, it looks like all located in peribasal. So maybe we need to look at the peribasal area and you look at the chloride levels. Maybe something wrong over there. The next one, please. Next one, okay. And you know, this slide shows the top. Okay, just give you, you know, some conclusions on the hydrological data used to collect and use and organize in a format we can apply it to conduct analysis between the hydrologic features and contamination in the salt area, and the relationship between chloride concentrations and well production is dynamic. You not just up or up, or down or up, both. And most wells with salinity problem located in basal aquifer area, and the trends of salinity concentration it generates increase over years in the salt area. And any questions? I think my time is up. And questions, if I still time, if not, you can, and send, contact me for any questions we can discuss later.
Thank you so much for that great presentation, Dr. Wang. As a reminder, if you have any questions or comments about today's presentations that are part of this meeting, you are more than encouraged to use our chat to share your thoughts, your comments, and your questions, and we will revisit that during our discussion section, which is slated for around 11:25 in today's meeting. Up next, before we transition, we'll be looking at a model of GIGO and the Tumon Basin by Mr. Thomas Aguila, and we'll just play a short introduction to that.
Hi, Amanda. Are you able to hear my audio clearly?
We are.
All right. Half a day and good morning, everybody. My name is Thomas Aguilo, and I'm a graduate research assistant at WERI. Under the advisement of my thesis chair, Dr. Habana, as well as Dr. Jensen and Dr. Leslie Aquino from the UOG Mathematics Department, my project is to develop a three-dimensional groundwater flow and contaminant transport model for the GIGO-Tumon Basin of the NGLA. During last week's advisory council meeting, Dr. Habana gave me such high praise. So I would like to say thank you to Dr. Habana, Dr. Jensen, my instructors, and all of WERI for all the support that they've given me since last year when I quit my job as an environmental specialist to pursue my master's. So thank you all for this amazing opportunity. During last year's advisory council meeting, I presented the intended plans for my project, and I am happy to present the progress we have made toward developing and using this model. Next slide, please. So this model will be a first for WERI. It is the first model to utilize both state-of-the-art groundwater modeling software and decades of quality data and research that WERI has accumulated. We are also building WERI's groundwater modeling capability by establishing a working relationship with the modeling experts at Brigham Young University, and by paving the way for future modelers at WERI. Our model can also help answer questions about the sustainability and contamination of our precious aquifer without having to spend thousands and thousands of dollars to dig holes hundreds of feet deep into the ground. Next slide, please. The GIGO-Tumon Basin is the most reasonable starting point for the development of a model of the entire NGLA. You may have heard that 80 to 90% of Guam's potable water comes from the NGLA. Well, a little over half of the water drawn from the NGLA comes specifically from the Jigo-Tumon Basin. Dr. Jensen has also said that the NGLA has the characteristics you would want if you could design an aquifer, and the Jigo-Tumon Basin demonstrates them, where water quickly enters the aquifer from the ground surface, but slowly exits at the coast like a bathtub. The data and research on groundwater in this basin is more than enough to develop a quality groundwater model. Next slide, please. Our model encompasses the phreatic or saturated layer of the Jigo-Tumon Basin, shown in this figure as the areas in green and teal. This figure shows the contours of the volcanic basement as determined by Van et al. And used in previous models, which were used to delineate the different zones. The green area is the basal zone, where the freshwater lens lies over the denser saltwater layer. And the teal area is the parabasal zone, where the volcanic basement is still below mean sea level, but the saltwater toe on average does not extend into this zone. The blue inland area, the suprabasal zone, is where the volcanic basement goes above mean sea level. So water flows along the slope of the basement from this zone into the parabasal zone. All right, next slide, please. Using the boundaries of the phreatic layer, we used ArcGIS to extract the data we need, including production well and observation well data, as well as hydraulic conductivity zones. These shapefiles were imported into Aquaveo's groundwater modeling system, or GMS, and used to develop a conceptual model. From the conceptual model, a two-dimensional mesh was created with refinement around wells to get more precise calculations at well points. Then elevation data was added to turn the 2D mesh into triangular irregular networks, or TINs. And finally, the TINs were connected to create our three-dimensional mesh here on the bottom right. All right, next slide, please. Hydraulic conductivity was assigned to elements in the mesh based on regional values established by Rotzel et al. And Gingrich. They found that Mariana limestone on the outer coastal edges had lower horizontal hydraulic conductivity of about 3,600 to 25,000 feet per day compared to the inland Barragata limestone with a horizontal hydraulic conductivity of about 39,000 feet per day. This is what creates the bathtub effect. Higher hydraulic conductivity inland allows water to quickly enter the aquifer, while lower hydraulic conductivity at the coast slows the rate that water exits the aquifer. Next slide, please. And if you could play the video. Great. So after a lot of trial and error, we were able to find the right settings to simulate saltwater intrusion. We started with the aquifer filled with fresh water, then allowed salt water to come in from the coast while still maintaining the coastal groundwater discharge. The different colors in this video represent different chloride concentrations, with green representing a 50-50 mixture of fresh and salt water, and red representing pure seawater. Water with chloride concentrations less than half seawater is displayed as colorless in this video, and the sheet of blue marks 250 ppm chloride, which is the EPA secondary standard for drinking water quality. As you can see, we successfully created a freshwater lens in GMS that mimics the characteristics of the NGLA and floats above the intruding seawater. All right, next slide, please. All right, we are currently in the process of calibrating our model to the available historical data. This figure shows all the wells that are included in the calibration. We have water level data from observation wells, then from deep observation wells, which penetrate both the fresh and saltwater layers. We have water levels and salinity profiles. We also have production rates and chloride measurements from production wells. With calibration well underway, we can soon simulate scenarios and make predictions. We will be looking at underperforming wells or those with low production and high chloride. In this figure, the color of production well dots represents the average historical chloride concentration, with orange and red dots representing chloride greater than 250 ppm, the EPA secondary standard. The text labels for production wells are color-coded by average production rate, with red labels indicating a monthly average of less than 100 gallons per minute and orange labels indicating 100 to 200 gallons per minute. For our simulated scenario, we will be taking underperforming production wells and moving them to prime locations, which we are defining as locations with the following criteria. With that they're within the sweet spot or parabasal zone. 2, that they belong to GUAM and are not already developed. Number 3, accessible by existing roadways and with access to existing power lines. All right, next slide, please. All right, we anticipate completion of the project and writing of my thesis and technical report in the spring of 2021. If you have any questions or comments, or maybe if you'd like to discuss ways that we might use groundwater modeling in future projects, please feel free to send me a message here or via email at aguilot@triton.uog.edu. I look forward to hearing from you. Thank you. Si Jis Masi.
Thank you so much, Mr. Vila, for that great presentation. As you mentioned, you can definitely share your comments and your questions. You can share it in the chat, and we can discuss it later during the discussion portion. Up next, we do have a presentation on coastal discharge mapping and remote sensing. Unfortunately, Ms. Maria will not be able to join us due to some connectivity issues, and we will be sharing her presentation later through email, and we'll also be sharing that as part of our final recording of this meeting, which we will release later. But with that said, it's a pleasure to introduce Ms. Eliana Walker, who will also be making a presentation. Ms. Eliana, whenever you're ready.
Yes, good morning. First of all, can you guys hear me?
We can hear you clearly. Thank you.
Okay, thank you very much. Good morning, everyone. My name is Eliana Walker, and I am a graduate research assistant with working with Dr. Romina King on identifying, mapping, and analyzing fresh groundwater coastal discharge with an unmanned aerial vehicle or UAV and a thermal infrared sensor. Next slide, please. Okay, so what is fresh groundwater coastal discharge? First of all, this is a hydrological process that typically occurs in coastal areas. It is driven by the combined influence of hydrogeologic, oceanographic, and climatologic processes. So groundwater coastal discharge is what occurs to rainwater after it has infiltrated the surface, percolated through the limestone in the NGLA, and reached the storage part of the aquifer. This less dense water will migrate then towards the coast and will discharge, forming plumes of actually cooler temperature than the seawater that it discharges into. On the bottom left, groundwater discharge can happen above sea level as near shore groundwater discharge, or NGD, below sea level as submarine groundwater discharge, or SGD, and at the coast as coastal groundwater discharge in the form of springs, diffuse seeps, and spring caves. On Guam, previous studies have already identified known points of coastal groundwater discharge, and they are depicted as red dots on the middle map, and I'm not sure if you can see very well, but they're all along the northwest coast of Guam, delineating the west coast of the NGLA. In 2013, also, there was a numerical model of discharge that estimated the greatest amount of groundwater discharge emanating from the NGLA in the areas of Haputo Bay and Tumon Bay. In fact, In 2017, it was also estimated by another graduate student, 2.4 million gallons per day discharging at Atutu Cave, a known spring cave within the Haputo Ecological Reserve area. So why do we care about groundwater coastal discharge? Well, first of all, it is groundwater discharge is part of the hydrological cycle. It is also known to move nutrients and pollutants from land into adjacent coastal waters. This is a known fact that overfeeds coral reefs due to the excess amount of nutrients. Groundwater discharge also has a unique cooler temperature that can change the sea surface temperature of the ocean waters it discharges into. Next slide, please. And next. Thank you. So because of the highly dynamic temporal nature of fresh groundwater discharge, and because it's very difficult to see these plumes, I am studying fresh groundwater coastal discharge from the remote sensing point of view. And to do so, we are armed with an unmanned aerial vehicle and a thermal infrared sensor. So in the top left slide is the very first image that we took with our drone, and we can tell temperature differences. The darker blue, as you can see, has lower temperature than the surrounding either land or the water as well. So we know that the fresh groundwater plume is the darker blue, emanating from Atutu Cave in particular in this picture. The second question is, we want to know, is there any relationship between physical factors such as wind, rain, tide that affect the surface area of this plume? Do these factors change the shape and the area? Next question will be we're trying to identify is there any relationship between the proximity of known coastal groundwater discharge points and the surface area of these plumes? And that lastly, it will be for us to find a relationship, if any, of any geological coastal features such as faults, and do they affect the surface area of these plumes? Next, please. So my primary objectives to answer these questions are first to collect high resolution thermal infrared imagery with this drone. And this is done by either flying at different altitudes, depending on what we're looking for. These are missions, what we call missions that are done either manually or automatically. Once we collect these images, we can then create a thermal infrared panorama or mosaic of Guam's northwest coast of coastal groundwater discharge plumes. Then another objective is to get these high resolution thermal infrared images and overlay them on existing GIS data sets. And for that, they will have to be geo-rectified. And of course, to answer our research questions. Next. So how do we go about capturing thermal infrared images of coastal groundwater discharge? So first of all, we create missions with the help of mapping software. So here we are in front of Atutu Cave from the boat. And the first thing will be to create our mission. The second part will be to fly the drone above sea level. And then the third part will be to start the mission, which the drone does on its own automatically. So what I am seeing in my remote control is real-time imaging first of RGB. So right now we are flying above Atutu Cave. Next, please. So here we are above Atutu Cave, and can anyone see the coastal groundwater discharge plumes? Not yet. But then our thermal infrared sensor will be on. And next, please. And now we can actually see this fresh groundwater coastal discharge plumes depicted here in darker blue because they have cooler temperatures. So now we can see these are previously recognized points of coastal discharge that were identified by these previous studies. Thank you. Next. So some of the preliminary results on the left image, we have some of the images that we've taken already around the Haputo Ecological Reserve area that have been stitched together to create this thermal infrared panorama depicting the groundwater discharge plumes in darker blue. On the right side, the area enlarged is right above Atutu Cave. And as we can tell, physical factors such as tide does have an influence on the surface area of the plume. We've been able to see that already. So during a falling tide, for example, in the middle of the slide, we have an image taken at 1457 when the tide was negative 1.9 feet. And then on the bottom, the image taken an hour later, negative 2 feet. And we can see the area of the plume delineated in white, darker blue, has changed. The same with rising tide. The above picture was taken at 1311 when the tide was 0 feet, and then at 1511, 2 hours later, when the tide was 0.3 feet. So we know that tide does change the surface area of the plumes. We also, for the other physical factors such as winds and precipitation, we are actually hoping that we can get over this pandemic so we can go back and take more pictures during those conditions where we have, for example, trade winds as opposed to calm winds during the summertime. The images on the right were taken at 40 meters above ground level. The image on the left was taken at 115 meters above ground level to create the mosaic. Next. Okay. Does anyone have any questions?
You know, I saw in Hawaii, they were using the airplane, you know, instead of, you know, now you are using the, you know, the other things, you know, the drone, these things. Can you, but they use the airplane, I remember. And then another thing is, you know, in Okinawa, okay, in Okinawa, they were building like a dam, you know, in front of the fresh water that is leaving the aquifer. They make like a storage, and they were using the water for irrigation and all that stuff. Have you checked those things, or is it significantly losing, you know, for Guam? I mean, I don't know.
So thanks for the question, Dr. K. Primarily the use of airplanes, it depends on the scale that you're researching. If what you're researching is a large area, then airplanes, because they can go up higher, can give you a better picture.
Yeah.
For our purpose, the UAV is definitely the way to go because we can get a little bit lower and get a much higher resolution.
Yeah.
We also have, by the way, we have air restrictions for the drone. We cannot fly about 400 feet. So we have to, that will be our max ceiling to not exceed.
Yeah. All right.
But it's a question of scale primarily. Yes.
Yeah.
Thank you.
Yeah. Yeah. Okay. Thanks.
Thank you. Any other questions? Okay. Well, thank you. Thanks everyone for listening.
Thank you so much, Ms. Eliana, for that great presentation. Once again, just as a reminder, if you have any questions or comments, you're more than welcome to share in the chat. I know that, for example, for Mr. Thomas Aguilo's presentation, there are a couple of questions and he's actually responding now. So we encourage you to share those comments and those questions throughout the meeting. And up next, we'll actually be having a short break. So take some time to stretch out your legs, take care of some side things for the next 10 minutes. We will actually be sharing the WERI Water Quality Lab video that was unveiled on day 1 as part of our break presentation. So stick around and we'll see you in 10 minutes.
Hello, my name is Barry Kim. I'm the WERI faculty member and serve as the coordinator of WERI Water Quality Analysis Laboratory. In 1980, the WERI lab was established to assist water quality research. But as demand for water quality analysis increased in the local community, the WERI lab has offered commercial services since 2001. WERI lab is the only water quality analysis lab on GUAM, so we try to keep supporting the community's needs, as well as keep enhancing analysis services. This video introduces what we do, how we collaborate with the local community, and what we have planned to expand the lab services. Enjoy watching this video. Thank you.
The Water and Environmental Research Institute of the Western Pacific, also known as WERI, was established at the University of Guam in May 1975. The role of the institute is to facilitate and conduct high-quality research that addresses water problems and water-related phenomena, train students, teachers, and future water resource professionals, and disseminate research results to the community at large. Consistent with the regional role of the university, the institute devotes part of its program effort to Western Pacific Islands other than Guam. It is the only research center of its type in this geographic area and endeavors to respond to the unique conditions that exist here. The institute draws from the varied expertise of its research faculty members, University of Guam faculty, research affiliates from other universities, and local professionals. In 1980, the WERI Water Quality Analysis Lab, also known as the WERI Lab, was established to assist WERI researchers in water pollutant analysis.
My name is Jennifer Cruz, and I'm the laboratory manager of the Water Quality Lab.
My name is Crispina Herrera Tagudin, Lab Tech 3. I started at WERI December 1985.
My name is Mallory Duegius, and I am the chemist at the WERI Water Quality Laboratory.
My name is Lourdes Mofness. I'm a graduate student in the ED program, but I'm also a research assistant too over at the WERI Lab.
The Water Quality Laboratory was first established in 1980 in House 28 of the Dean Circle, and it moved to the current WERI building in 1990. The laboratory was established to support research for water quality analysis. But in 2000, the lab was certified for the testing of total coliforms and E. coli, as was led by GUAM EPA. This was to support the lead and copper rule that US EPA had regulated. Since then, no other testing parameters were certified until we hired a chemist in 2016, where now we have the manpower to offer more services as far as certified testing. In 2017, we added certification for the heterotrophic bacteria analysis. This was requested by many of the food establishments who are serving the military bases. And the same year, we added nitrite and nitrates in our certification. The last certification that we obtained was in 2018, which is for copper testing.
I conduct instrumentation analysis as well as conduct microbiological, organic and inorganic analysis.
I have to go out in the field and collect samples from all the construction sites. New buildings, new residential areas. I have to go out and collect samples for lead and bacterial tests.
Part of my duties is helping making reagents and standards, and also helping analyze the samples we get. So that includes metals analysis and nutrients analysis, in addition to bacteria analysis for the water samples.
Some of the instruments we have in the laboratory are atomic absorption spectrometer, which is used for lead testing in other metals. And then we also have the flow injection analyzer that we use to analyze nutrients in water, such as nitrates, ammonia, and phosphates. We also have a gas chromatograph, which is set up for the PCB analysis for research purposes. And of course, we have the standard lab equipment such as the pH meter and tubular meters. In addition to the total coliforms, E. coli, and heterotrophic bacteria, we also analyze enterococcus bacteria, which is used to monitor surface water or recreational waters on Guam. Our customer base consists of construction companies and consulting companies, but we also have food and beverage establishments, hotels, airlines, and other government agencies. We also serve companies and other organizations within the region, such as CNMI and FSM.
WERI officially became the first regional water resources research institute in the WRRI program by extending its mission to the Federated States of Micronesia, or FSM, in 1991, and to the Commonwealth of the Northern Marianas, or CNMI, in 1997. The designation has opened a broad new spectrum of research and service opportunities for the University of Guam.
Out of the 54 water research institutes in the country, we are one of only 2 that have a water quality laboratory. That's one of the reasons that we are highly rated. In fact, we're one of only 12 institutes that received the top rating of outstanding in the last 5-year review. We've been consistently in the top rated category for the last 25 years.
WERI Lab has really been developed over the years to support academic purposes such as research and student learning. And as more demand for research and study has come to the University of Guam, we've seen investments in the lab increasing. And those investments are tangible investments like equipment and facility and supplies, materials. But it also has brought us expertise. We've been able to hire lots of folks into the lab, those with specialized training in lab services as lab technicians. And we have our academic faculty who, through their research projects, utilize the lab and the resources in it. The community, they may not see that directly right away. We do have a number of businesses who are familiar with the lab and do work closely with the lab when they need tests of water quality done.
With an expanded lab, that includes an expansion of resources, and that's significant to me because as a student, I find it important that resources are available to help educate me and further my experience as a lab and research assistant. So most of all, I think it's significant to the DOG in addition to the people of Guam.
The expansion of the laboratory would help create some positions for newly graduates who are looking into environmental compliance, who are interested in laboratory analysis, and open up some positions for undergraduate internships.
It has grown from just supporting research to offering services to the community of Guam and the region. And it still has a lot more potential to grow and benefit more students for internships and also for the local companies who need to send samples off island.
The government beneficiary of this in its public services, the public assurance of water quality and water safety, and working with GWA on some of those water quality tests. With the future design plans for a new building for WERI, the lab space will greatly increase, and thereby we'll have the room for that equipment, and we'll also have room for more personnel.
UOG and the whole island are really fortunate to have an asset like our water quality laboratory. Besides supporting research and providing a low-cost, readily accessible service to our clients and customers on the island, it leverages our local talent by providing an opportunity for students to get hands-on experience where they'd never be able to do it otherwise without going off island for it. I'm excited to see it expanding and looking forward to continuing the service that we provide to the island and to the students that train in it. It's one of UOG's crown jewels.
Half day, everyone, and welcome back to the Day 4, GUAM Part 2 for the WERI Advisory Council meeting. Up next, we have a presentation by Dr. Chris Yeo of WERI. He will also be giving 2 presentations today, and I'll go ahead and hand the floor back to Dr. Yeo.
Hi. Hello, everyone. I'm Chris Yeo, Assistant Professor for Surface Water Hydrology. Today, I have 2 talks consecutively. Here is my first talk, Numerical Assessment of Submarine Groundwater Discharge. Please click next, please. Next, please. Before showing my research topics and research, I'd like to talk about what submarine groundwater discharge is and why it is important. It is defined as a portion of water discharged into the ocean across the hidden ocean-land interface. Especially fresh SGD is controlled by hydraulic gradient between the water table and the sea level. Because of the difficult observation and measurement, SGD has not been considered as a major pathway. However, it is not true. Next, please. Although the volumetric contribution of fresh SGD is comparatively minor to rivers, the nitrate level in SGD is at least 2 or 3 times to typical coastal water. Using high technologies such as UV images or satellite, recent studies refer that fresh SGD is an important transport pathway for nutrient, heavy metals, and organic compounds. So the main objective of this project is to describe the nutrient convection and diffusion properties and mixing mechanism along coastal line. Next, please. Here is the study area. Azus Cave is the largest coastal cave on the western coast. Because it is a coastal cave, there's many limitations to access there. For example, it's low tide, so it is impossible to measure, or it is impossible to get there at a high tide. Next, please. In order to account for the convection and diffusion properties of nutrient and mixing phenomena, I developed a 3-dimensional computational fluid dynamics, CFDs model. Here is the computational domain, 40 by 20 by 10 meters, to represent a typical shallow coastal system around the study area. The total number of mesh or total number of grid is 1.2 million. The shapes and location of coastal reefs are arbitrary. This study covers low and high tide condition for looking into tidal effect on flume shape. Next, please. In addition to the numerical modeling works, water samples were carried out at the cave pool and cave entrance in September 2019 and June 2020. As you can see the table, it is found that the nitrate concentration in the cave pool do not change much over time. However, the concentration at the entrance was measured 9% lower than inside. And also due to the limited grant amount, it was not to perform the water quality test for a long time period. So another possible plan is to investigate the time variation of nutrient in the SGD. Next, please. SGD flux is function of hydraulic gradients. It means the amount of SGD is time varying with respect to tide conditions. So due to the limited access chance, as I mentioned in the previous slide, the flood velocity is constant, I set up a constant velocity as a 0.2 meter per second. Based on this information, I set up the initial and boundary condition for the CFD simulations. Next, please. In order to easily figure out the features, I conducted the simulations with respect to vertical and horizontal planes. Here is the 2D vertical result. Left side is for high tide condition and right side is for low tide condition. These figures represent when cold fresh water or fresh groundwater is discharged to relatively warm seawater. How the cold groundwater is mixed with the seawater. In the case of a low tide condition, the channelizing effect created by the tide condition and coastal reef height makes the discharge goes out in, it's okay. Next slide. Goes out in on one direction. However, for high condition, after deflecting due to the coral reef, the discharge could reach out the coral cliff side. Here's bottom two figures is a nutrient diffusion mechanism. This mechanism shows a similar pattern to the temperature dispersion. Next slide, please. And one more click, please. Here's a horizontal simulation result. In order to investigate the location and shape of coral reefs, I changed the 3 or 4 locations, but I kept exactly the same boundary condition. Click one more click, please. From these 2D vertical and horizontal simulation, we could conclude that horizontal freshwater plume shapes are characterized by the location and shape of coral reef, and vertical shapes are described by the tide condition. Next slide, please. This is for 3D simulation result. I did stationary condition. So this slide shows 3-dimensional velocity distribution. Next slide, please. One more, please. For the future plan, I took these pictures September 17, 7 a.m. for Pago River and Pago Bay. Of course, there was a storm around 5 a.m. However, it was not severe. Seawater temperature rise and high turbidity caused by sediment and eutrophication have been regarded as a major threat to coral reef health. I believe coral reef related business is one of the major revenue sources for Guam. The coral reef conservation is crucial for Guam economic development. Next, please. So I'm planning to extend this numerical model to river authorities for figuring out the nutrient and sediment transportation mechanism. In addition, my master thesis proposed a CFD model for improving wastewater treatment plant efficiency and determining the optimum operation conditions. So I'd like to implement this CFD numerical analysis for small island wastewater treatment plant in CNMI, FSM, as well as Guam. Also, this model can be used for hydraulic structures failure, such as breach and some convert. Next slide, please. Next slide, please. This project was supported by Guam, NASA EPSCO, and SEED grant, and Guam EPSCO SEED grant. I'd like to express my many thanks to the coordinators. My simulation results will be posted to both NASA EPSCO and Guam NASA EPSCO homepages. Next, please. Because I have 2 talks, so I presented very quickly the first slide, the first phase. This is my second talk. I will introduce one of my research topics, the first phase of stormwater studies for Tumon Guam. Now I'm building up a general stormwater and flood frameworks for Guam and CNMI. So this this presentation is almost the same as CNMI presentation. Next slide, please. Extreme storms and the following floods account for more losses than any other natural disaster. In addition, increasing trends in the number of extreme weather events, such as storms and floods, have been observed around the globe. In order to prevent or diminish the flood damages, understanding the variation of rainfall processes in time and in space is essential for the planning, design, and management of various hydraulic structures. Next, please. Design rainfall is to estimate the maximum amount of rainfall at a given site for a specific duration and return period. Result of this statistical analysis can be summarized as the intensity, duration, frequency, IDF relations. Click, please. Here is an example for IDF curve. We can calculate or we can estimate extreme rainfall intensity corresponding to return period and duration. In this case, rainfall intensity for 25-year return period, yellow line, and 60-minute duration, and blue dot, is 30 millimeters per hour. Click, please. However, with the traditional IDF estimation method, we have 3 challenges: time and space scaling issues and climate change. I will explain the time scale issue and climate change problems in detail. Next, please. Temporal distribution of rainfall is critical for estimating accurately hydrologic responses. Click, please. Montreal Airport in Canada measured a storm with different time intervals. Red line is represent 1 hour interval, and black line does 10-second interval. Can you imagine the following hydrological responses to these 2 cases? I believe there is no doubt at all. They are completely different. Of course, these data are correct. I don't want to say one is wrong, one is right. I just want, depending on our purposes, we must use data with appropriate time scale. In modern study, there's a general statement. It is garbage in, garbage out. It means even though model is completely perfect, if the model should generate wrong output if we use wrong input data. This is the reason why we need to find temporal resolution data for stormwater and flood estimation. Next, please. This is a probability density function PDF plot. From this PDF, we can estimate rainfall intensity or flood discharge corresponding to probability or return period. So when determining the target storm event or floods, hydrologists have been using these types of PDF. In this case, the area for red colored region is 0.1. This 0.1, 10%. This 0.1 area represents 10-year return period. So X1 is the extreme storm intensity or quantile corresponding to 10-year return period. Like this procedure, we could estimate any intensity for 50 years or 100 return period. For 50 years, the area is 0.02. For 100-year return period, the area is 0.01. Based on this information from the PDF, we can set up building code or hydrological design. Click, please. With the increasing mean and standard deviation caused by climate change, the PDF should be updated like this. There are 2 main aspects. First, the rainfall intensity corresponding to 10-year return period is updated from X1 to X2. It implies hydrologists should reflect these updated information to hydraulic structure design or building code. The traditional method is likely to underestimate the intensity. it could result in failure, some broken something. Second, the extreme event X1 will be observed more frequently under the update condition or climate change condition. Next slide, please. In order to solve both timescale problem and climate change impacts, I proposed a temporal downscaling method to estimate sub-daily and sub-hourly annual maximum rainfall intensities from historical or projected future daily rainfall time series. Fortunately, my research article was published to the International Journal of Climatology in July 2020. In this, my journal, I introduced another new confidence interval estimation method to capture uncertainty in the IDF curve estimation. Next slide, please. Numerical procedure, a very complicated numerical procedure and computer programming works are required for the temporal downscaling and confidence interval estimation. Hence, I decided to develop assessment tool or software so that everyone can easily assess or use my model. This software is called SD Extreme. When the first COVID lockdown hit GUAM from April to June 2020, I finalized the development of the second version of this tool and submitted another manuscript, including the software, to top journal. Click, please. I tested this software with two historical records from Seoul, South Korea for subtropical region and Montreal, Canada for cold region. From these applications, my model was verified and validated. Using this historical data set, these tools produce both graphical and numerical IDF curves automatically, as well as the confidence interval. Click, please. Another challenge for hydrologists is how to quantify climate change impacts on hydrological processes. This is the most critical issues, especially extreme events such as drought or flood. Click, please. Global climate model, GCMs, have been extensively used in many studies for assessing the impacts on hydrological processes. However, outputs from these models are not suitable for the climate change adaptation and mitigation studies due to too coarse spatial scale or resolution, generally greater than 200 kilometers. So we need additional procedure. It is a downscaling step in space. So with the demands, another software, SD-RAIN, I developed was published to the Journal of Water and Climate Change in December 2019. Click, please. I use 3 climate change scenarios, ICP 2.6, 4.5, 8.5, provided by CAN-ESM2, CIMI5, Canadian Climate Change Model, with SD-RAIN for Seoul and Montreal stations. And then the projected future daily rainfall time series were applied to this SD Extreme software in order to structure and construct future IDF curve. Click, please. Finally, I could compare how much extreme rainfall would change with respect to different climate change scenarios and with respect to time frame, such as 2020, 2050s, and 2080s, like this picture. Next slide, please. This slide is my last slide for 2 talks. This slide shows my 5-year research plan. For the first phase, my team, my master student, and I are doing a site and regional frequency analysis. Next, please. And then stormwater management models will be proposed for estimating peak discharge and assisting a standard guideline protocol for the low impact development LID. Once my manuscript accepted, I'm planning to convert the developed software to web-based IDF curve estimator for the public. And then in this phase, the temporal downscaling model will be proposed for estimating sub-daily and sub-hourly extreme storm events. Next, please. For the following phase, I will couple the stormwater management model to various climate change models for future flooding simulation. And expected my final output would be a real-time flooding alarm system. It would be smartphone app or texting. Next, please. By collaborating with Dr. Nomira King, the first two phases are granted. I believe she and I will prepare another project for the remaining and/or the coming demands in the future. Next, please. Thank you. Because I have two talks with just 20 minutes, so I spoke very quickly. So, but I wish you can get my information. Thank you.
Very good. You know, Chris is really good. We can use it for the project that we're going to do with the National Science Foundation. It's very good.
Thank you so much.
I'll talk to you later. Yeah, more.
Thank you.
Very good.
Thank you so much, Dr. Crisio, for that great presentation. As a reminder, if you have any questions or comments, you can share them in the chat. Dr. Yo can respond to you there, or we can save that for discussion session as well. Up next, we're going to go ahead and give the floor to Dr. Patel from the UOG School of Engineering, who will talk about the geotechnical characteristics of Guam soils. So, the floor is yours, Dr. Patel.
All right, thank you very much, Michelle. So, welcome everybody. My name is Ujjwal Patel. I'm an assistant professor in civil engineering at UOG's School of Engineering. So the topic of my research project is geotechnical characteristics of Guam soils. I think I lost the presentation, Michelle. Okay, great, thank you. Okay, so the topic is geotechnical characteristics of the Guam soils. Special emphasis is given to the soils collected from along the hill slopes in the southern watersheds. And based on the soil testing results, we also did some slope failure and landslide investigations, which I'm going to present today. So this project is funded by GUAM Hydrological Survey. So thanks to them. Next slide, please. Okay, so this is the outflow, the project outline. We started with identifying the site locations. So we chose the first site as Fina Dam slopes because there is an issue of excessive sedimentation in the Fina reservoir from the slope failures. So we chose this site. The second site was from the Inarahan watershed, and the third site was from the Aiha watershed. So we flew the drone and collected the slope failure pictures. We also did some physical inspection to map the soil profile, which can be used for our analysis. We collected the soil samples from these CHOF 2 layers and brought them to the lab and did some geotechnical engineering tests in our UOG lab. So we did some specific gravity tests, sieve analysis, hydrometer. We also constructed the particle size distribution curves, did some plastic limit, liquid limit tests, compaction tests. So we characterized the soils that we collected from those 3 watersheds from along the hill slopes for the engineering properties and classified them according to the unified soil classification system, which is like engineering way to classify the soils. We also did some saturated permeability tests on the undisturbed samples in the lab using the KSAT equipment. We also did the field permeability test using the dual head infiltrometer and mapped the minimum and maximum values of the hydraulic conductivity of the soils in all the 3 watersheds. Basically, permeability tells us that how much amount of water will flow through the saturated soil. But in reality, we might have soil that is unsaturated. So how do we model the flow of water through unsaturated soil? So we do another test called as soil water retention test, with the help of these two sophisticated equipments, which are computer controlled. So we run the test and we get these experimental points. And we use this mathematical model to best fit this curve to get this SWRC profile. So the most important thing about this SWRC profile is that it tells us that what is the water retention capacity of the soil. So when rainfall happens, then how much amount of water will infiltrate into the slope and how much water will result in the runoff. And we know that runoff is useful for the design of the drainage to prevent the flooding. We also did some shear strength tests, that is collected the undisturbed soil samples and tested in this computer controlled direct shear test apparatus. And we extracted the information in the form of the saturated shear strength parameters such as effective cohesion and friction angle, which is important to characterize the shear strength of the saturated soils. Then we combine them with the SWRC parameters that we obtain from this SWRC profiles. And we can calculate the shear strength of the soil corresponding to any volumetric water content at any time of the year. So now we have a complete control over the flow of water through the saturated soil, unsaturated soil, as well as over the shear strength of the saturated and unsaturated soil. So now we are ready for our analysis. We also did some field instrumentations and installed some suction sensors, moisture sensors, rain gauge station at the IHA site and collected this 1+ year of data. We also captured some nice typhoon events. And this is the monthly rainfall for 1 year, 1+ year. And you can see that on the November 2019, we had like 16.6 inches of rainfall. So we chose this for our analysis. So we use that 1 month rainfall data and convert it into the 26 days antecedent rainfall and use the actual storm event, Storm Kamburi, which dumped about 7.22 inches of rainfall in 24 hours for our analysis. So the first analysis is transient seepage analysis. So what happens when rainfall occurs and how does the water flow through the slope? That we are trying to model. So we idealize the hill slope as 45 degrees, input all the soil layers, input all the geotechnical and hydrological properties that we obtain from our lab testing. We assign the boundary conditions, apply the rainfall, and then we run the simulations. You can see that on the first day, it represents the dry conditions. So we have very high negative pore water pressure. And after 26 days of antecedent rainfall, the pore water pressure in the top layers, it reduces. And on 28th day, which is almost immediately after the storm event, you can see that the top few feet of the slope surface has become saturated. And there is a drastic change in the pore water pressure from -350 kilopascal to almost 0. And this can cause the instability and slope failures. But whether the slope will fail or not depends upon the slope stability analysis. So we use another finely living method program to run this analysis. Now we input the saturated and unsaturated shear strength parameters that we obtained from our rather sophisticated test that we did earlier. And we also import all these transient pore water pressure profiles and run almost a 1 month of analysis. Okay, sorry, I think I'm going too fast. Okay, so the output of this stability analysis is in the form of factor of safety, which is a dimensionless number. And when factor of safety is less than 1, slope fails. Factor of safety greater than 1 means slope is stable. So the output is here. The red line indicates the 45 degrees hill slope. And it never crosses the factor of safety of 1. It means that 45 degree slopes are stable. Whereas the blue line indicates the analysis for 1 month for 60 degrees hill slope. And you can see they fail multiple times. So in IHA watershed, for which this analysis is done, we can say that 45 degree slopes are stable and 60 degree slopes are unstable. We also use this 1 year of rainfall and did the analysis for 365 days, and similar results were obtained for 60 degree slope. We did analysis for hill slopes in FINA watershed as well as the Inarahan watershed, and all those results will be documented in the final report. So the analysis that we did earlier was a 2-dimensional slope stability analysis, assuming that the slope surface is plane. But in reality, we have like very complex geometry of the hill slope, and we need to take into account that complex geometry. So we use the LiDAR data and create the contour maps. From that, we can generate this 3-dimensional digital elevation model, which I am showing you here. I don't have the software for the 3D analysis yet, but hopefully I'll get it by next month, and I should be able to run the analysis. The output will be something like this, showing the heat map with locations and timing of failure so that we can go back and we can repair the slopes before they happen. Okay. These are some of the major conclusions which I summarized in the previous slides. And this slide is not from Guam, it's from Taiwan, I believe. We don't have FIOs in Guam. But in southern Guam, we have roads that passes to the hill slopes from the at the foothills of the slopes. And those slopes are like very steep slopes or they are vertical rock cuts. And we know that these rocks are undergoing weathering process. So with time, they are going to degrade, and something like this slope failure we can expect in future in southern Guam. So just wanted to put that slide. So with that, I would like to end my presentation. And if you have any questions, I'd be glad to answer. Thank you.
Thanks so much, Dr. Patel, for that great presentation. I actually have a request from Ms. Sanji Luhan, one of our great friends from the AWWA HIWPS. She's asking if you can go back to your conclusion slide. So Michelle will take care of that now. I also do want to acknowledge the presence of one of our legislators, Senator Kelly Marsh. Thank you for joining us today for our advisory council meeting. And so up on the screen, we do have the conclusion slide back up for Ms. Sanji. We're actually going into open discussion next. And so if there's any questions for Dr. Patil, and then we'll also hand over the floor back to Dr. Jensen. So Dr. Jensen, we'll be spotlighting you now. Also, as a reminder, we had some technical difficulties earlier. After our agenda items, we will actually be playing Ms. Mallory Duenas' presentation later on. It's not on the agenda, but we encourage you to stick around. It'll be a great presentation. And we encourage everyone to join us to learn more about potentially impacted PFAS sites on Guam.
Yeah, we're going to keep on schedule because we know everybody has scheduled commitments, but we're bringing Mallory back for an encore performance for those of you who can stay on. And we'll just keep the meeting running until she's done, but we'll stay on the regular schedule until then. So I guess we go back to the question posed to Dr. Patil by Vanji Luhan, and that can be our segue into our discussion here.
So I don't see any question, Dr. Jensen. I think she
I
just wanted to see.
I have a question. It's very interesting. Yeah, we can actually Chris, of course, the Chris is doing and Patil is doing is going to be very, very useful. And like for example, a couple of years ago in Panapet, that landslide happens and many, I don't know how many, 80 or 800 people got killed. Now, my question is how we can take care of it. Is it in a way, there is a lot of rain everywhere.
Yes.
And
so the best way is to, go green. We can make sure that there is always some kind of plantation there actually. And that is one of the another project that I'm doing with the Sea Grant actually, that how when you plant the slopes, then the roots, they reinforce the soil slopes, and they also induce suction. So the soil becomes a little bit drier instead of wetter, and its shear strength increases. So, but we have to determine that what plantation is suitable for those slopes, depending upon the slope angles and all those soil properties. So that is something that I'm right now doing. So this is the green solution, but there are other solutions also. Like we can, if the slope is like really important from strategic point of view, then we can go for cement stabilization, line stabilization. Some fibers can be added and recompacted to prevent the slope from failing. So there are multiple ways actually to repair the slopes and to prevent the slope failures also.
So can we use the pump to suck the water? In the soil,
No, unfortunately, that's not a good practice because pumps. If you have only water there, then you can suck out. If there are wells, if you can dig the wells, maybe you can then reduce the groundwater table. But the groundwater table is not an issue in our islands. Groundwater table is much deeper here because we are at a very high altitude. It's the rainfall induced. So all the analysis that I did is for rainfall, in response to the rainfall. So they are shallow slope failures, and the only solution is either do some kind of treatment like chemical treatment like cement or lime, which is not environment friendly, but you can do plantation. Make sure that there is always some kind of grass or plantation there, and that can really help actually.
Very good.
because it will prevent the water from infiltrating into the slope, as well as, but then there will be a runoff. So you have to also make sure that at the foothill we have roads, so proper drainage is provided. But we can estimate that runoff based on whatever we have provided on the slope.
Very good. Thanks.
Good question.
This is your opportunity to ask questions of any of the speakers, and also to make suggestions to WERI and the faculty on directions for research related to the current research that you've seen, or new ideas as well. If Amanda could put up the schedule, maybe so we can see the topics of the presentations, it'll be a nice little summary that we can work from. But I'd like to just put out a general invitation to anybody to just come on the screen and interject a comment or question.
We had before, we always had the from in the river, these things is the sediment, too much turbidity and these things. And I think the work that Chris is doing is very good. We can, for like a Pina Reservoir, they were saying is getting filled up. All the sediment and stuff coming. Yeah, that's good. Yeah.
I have a question also related to that. Have you looked at the areas in UGAM? Because I know for GWA, the stabilization in soil and erosion issues related to turbidity in the UGAM area. Do you have data there?
Not yet, because as you presented through my presentation, I got 2 seed grant. It's not big grant, so I want to make like a standard guideline or a protocol. After that, I want to extend this standard form to big rivers, UGAM River or other rivers, something like that.
Also, does your model take into account certain areas that are highly more susceptible to erosion or a landslide versus other areas within that individual watershed?
Yes, from last Thursday meetings, I had some time with Dr. Petil to discuss how to collaborate with he and I research work, because extreme rainfall is main cause for landslide sedimentation. So I believe a collaboration with him and I can give good result to government of Guam to protect our watershed and our coral coastal region environment.
Chris.
Thank you.
We have a data for, we did a project for Vanji before, and we had the data for erosion and, for turbidity for how many years? 2 years, 3 years for different rivers. We can give it to you. You can look at it.
Yes, thank you. But because I need to understand the local characteristics of watershed, first of that. So I want to set up step by step. So small watershed and bigger, and last time maybe Southern Guam or Northern Guam.
Yeah.
So to just add to Vanji's question, once I do the slope stability analysis, I can also estimate that how much amount of the soil is going to slide, so the volume of the soil, and eventually that is going to end up in the streams, rivers, and oceans. So that sedimentation load can also be calculated actually. So that is something that we are trying to see, that how we can convert this data into the sedimentation load to prevent.
We can actually, together work here. Yeah. That's very good.
Because Dr. K has done some studies, but it's been like 2012, 13, 14. So we need more data.
We can continue.
Of course.
Yeah.
I actually have a question in the chat. And Dr. Jensen, this actually might be for you. It's from Pete Diaz, who is actually one of our friends from AWWA HIWPS, and he is also part of the UOG Board of Regents. So hi, Mr. Diaz. His question is WERI looking at modeling sea level rise or stormwater surge analysis that would help for future planning for low-lying areas like Tumon, Hagåtña, and the southern villages? Great question, Mr. Diaz. I'm going to hand that over to you, Dr. Jensen, or if there's anybody from your team that
Yes.
you'd like to have answer that question.
Yeah,
Yes,
that's a good suggestion. I'll turn it over to Dr. Yeah.
Yes, I'm planning to make a project with Dr. Romina King because storm surge is major issues for coastal area because storm surge means because of a strong wind, sea level is rise. So it means storm water cannot be drained to ocean. So under the storm surge, is our flooding gets worse and worse. So it's most critical issues for coastal areas such as Boston and Louisiana, and last year's 2 years ago, Texas, Houston, same issues, storm water and storm surge. So I want to urge you, storm surge modeling is very, very important for our societies, such as Pacific Island. So I want to make some project with Dr. Romina King.
Yeah, it's actually EPA was very upset of the GWA. They were, it was talking about going to the court and this thing, and its all issue is the places that had a lot of turbidity or erosion or this goes to the beach was people that fishing, that area was fishing this. So that was really upset everybody. You're right. Yeah. We need to get together, you, Patil, and we talk about these things. I'm very interested. Yeah.
Hello.
Oh, Leo is here.
Can you hear me in there?
Yes, sir. We can hear you.
Okay. One thing, I think if you watched Dr. Lander's presentation on climate change, we are in a different world out here in Guam and in the islands. And just to say climate change is here, and this is how much it's going to be because the Arctic's doing this and that, that's fine, maybe in general for the world. But I think Mark did a really good job of showing just the effect of trade wind switching and how that's going to affect sea level and those kind of things. So we have to be very, very careful in applying these climate models to our situation. And I just think Mark Lander should have a really big input in any kind of climate change, trying to figure out who's going to get flooded and who's not going to get flooded, because he knows what's going on out here climate-wise, probably better than anybody else in the world because he's lived out here so long. Thank you.
Thank you so much, Dr. Heights. We also have a comment. I have actually a question and a couple of comments from Mr. Victor Torres. The NOAA Coastal Services Center had a sea level rise viewer that developed using bathymetric and topographic data. Before we get to Ms. Sanji's question, I'll just share from Dr. Romina King. Her response to Mr. Diaz: we are asking for FEMA money for a wave run-up model. This model will need to be placed on top of the storm surge model. The storm surge model is not enough. And then the question from Ms. Sanji I have is, will the groundwater protection zone study include an update of the map? So great conversation we're having here. If there's anybody who would like to answer Ms. Sanji's question, her question once again is, will the groundwater protection zone study include an update of the map?
Yeah, let me throw in a comment or two on that and then turn it over to the people working on it. The project that Kaylee briefed that she's doing under supervision of Dr. Nguyen is just a start of what will be a whole career for people who follow. And the first step is to just round up all of the factors that Kaylee mentioned that would go into a appropriate groundwater protection system and plan. And the map is really going to be one of us, what will eventually be a series of maps or map layers will identify all of these factors. And the direction that we're taking is to use the state-of-the-art best practices that are in place in other communities. There's a huge literature on this. And the other factor is that, as several of the speakers have mentioned, our aquifer is unique. Our water resource utilization system is unique in many ways that I won't go into on the spot, of course, but borrowing the best practices from existing models and adapting those to our unique situations is the essential aspect of this project. And again, I'll emphasize that it's just the beginning of what will be, in my estimation, a permanent project or permanent area of activity for us and the people who follow us. The other thing that this will integrate is economic considerations, land use and it's something that geographic information systems are designed to tackle this kind of project. So that was kind of a long answer, but this is a pivotal project that was suggested by Captain Bearden at GUAM EPA in one of our discussions, and one of the things that we're going to be partnering up with all of our partners to work on. And I'll turn it over to Dr. Nguyen or Kaylee or any of the other WERI faculty to comment on that.
Well, I have like a burden or proposed, to come up with that zone, zone this. I think that's going to be a big project. I think that's very good. All the factors affecting this needs to get involved,
Yeah, it's going to recognize the actual complexity, I think, of the situation. There won't be any one zone or any one one-size-fits-all model for something like this, and it'll recognize that there are different uses and different priorities. You put a different priority for the best part. You got to recognize there are some of the best parts of the aquifer and some of the parts that probably never be developed. So you don't want a one-size-fits-all model for the best zones to be applied to the marginal zones. And this will start by separating all that. So any other questions on, let's see, I'll let Amanda, she does a better job than I do of reading I can't read these chat lines without my glasses here.
Okay, thanks, Dr. Jensen. I'm going to share the comment from Mr. Victor Torres. I believe USACE did some wave run-up modeling for EPAN area. I guess the point here is there may be many studies already conducted for some natural events out there that may need to be found so as not to reduplicate, but further move on gaining scientific knowledge and eventually results. This is a great comment here. Well, it looks like we're actually coming to a close of our discussion section at this time, but I do want to encourage everyone, if you have any questions or comments, you can definitely still share it in the chat. We can make sure we send it to Dr. Jensen and his team so we can keep this conversation alive beyond the advisory council meetings. As Dr. Jensen mentioned earlier, one of the things that this meeting does is help guide the research agenda for WERI for the upcoming year. So it all of these comments, these questions, all of these conversations play a very important part when it comes to WERI's direction. So thank you so much for all those comments and those questions. We definitely appreciate that, and we'll be sharing those as well with WERI moving forward. With that said, we're going to move on to the next part of our agenda. I'm going to keep the floor with Dr. Jensen, and he'll talk a little bit more about one of his colleagues, the scholarship that was made in honor of him, the Dr. Joseph D. Rouse Scholarship.
Thanks, Amanda. Well, as a bridge to our next presentation, I'd like to share this moment with you to recognize the contribution that Dr. Rouse made not only to WERI, but to the launching of our School of Engineering that you're going to hear from an update here from my friend and colleague, Dr. Kay, here in a few minutes. Dr. Rouse was a wastewater engineer, and you've heard a lot of references to his work today. He led students in innovative research on applying local conditions to wastewater treatment, and he leaves a legacy of having not only brought students through the environmental science program, but having helped develop the curriculum and even advising students as we launched the engineering school. And he even chaired the search committees that hired most of the faculty for the engineering school. So he has a foot in both of these programs. And we launched a scholarship last year in his memory to keep his legacy alive, which most important features of his legacy, which is a large one, was how he stood for excellence and integrity in the application of science and engineering. So we launched a scholarship which will provide about $1,000 each year if we get the full corpus put together. That will support sending a student that epitomizes these values to professional development, to a workshop or to a presentation of his or her work. And we've raised about $20,000. We need $25,000 in order to get a return of about $1,000 a year, which is necessary for the goal or objective of the project. Incidentally, AWWA was one of the first contributors, corporate or organizational contributors, but we're inviting and encouraging all of you. The foundation will be sending out an invitation to each of the people who registered for our advisory conference to invite you to contribute to this, and I would be grateful and be grateful for whatever contribution you all can make to the memory of Dr. Rouse and to preserving his legacy as a role model for new environmental scientists and engineers whose careers are starting with their education and training right here at the University of Guam. So thank you very much. And with that, I'll invite Dr. Kay to give us an update on the School of Engineering and the exciting things that are coming down the road here that are going to be part of his legacy as the founding dean of the School of Engineering.
Oh, yeah. I have a question. This 25,000 gonna be in how long? 1 year or?
The 25,000 will go into the endowment, and it'll produce about $1,000 a year. So, you know, we don't have to stop at $25,000, but $25,000 gets us started, and it'll. If we can raise even more, we can give a larger award.
Timeline, right? There is no timeline for 25,000. It's not this year.
There's no deadline, but we've been fundraising for about a year, so we're hoping to have it in place here so that we can give the award here soon, maybe even this coming year. when you guys graduate to first class from School of Engineering.
Yeah, he's, oh yeah, I never forget him. He was a nice guy.
Yeah,
And
he left a big legacy.
yeah, yeah, sure. All right.
Okay, thanks. Okay, Shram, you have the floor here for the next.
All right. All right, John. Thanks. Really good meeting. Very
Better turn
good.
your video on, Shram.
Okay, where is my video?
It's down in the lower left-hand corner of the screen.
Is on the screen.
You know,
Start
you're
my video.
good
All
with
right.
technology. There you go.
I think. All right. So you can see me. All right. Well, let's change the subject. For first of all, I'd like to thanks for the senators. They're coming and they're gonna listen to me, to us, and let's change the subject. So far we have all the numbers, this, but this is fun actually. So just talking about the School of Engineering, we call it the SDNT, and this is a new school, is a new campus. Okay, so let's change the next slide. Okay, okay. I'm gonna first of all, I'm gonna congratulate to everyone. Now we have 4-year Bachelor of Science Civil Engineering, and it's really big things. This is the I was talking with some engineer or some consultant. Is really expensive for them to bring somebody from state to here, because first of all they have to pay good salary, and then they have to have car, they have to have this, so very expensive. So they're looking for local, somebody from the local, and okay, and really it's really something that moves. And I'm gonna appreciate to Dr. Heights too. He was, we start when we came to Guam, 2 engineers coming to Guam and say, what the hell we're gonna do? Some project we need. And then we start say, okay, well, how about teaching the courses? And then we put together we call it the 2 years non-degree environmental science program. And really that was a good program. And some students, they went to a state, and then they finished this, they got back home. And now it's so interesting when I go to the meeting and you see some of my students, and these are, these are big people, but they are like my kids. And it just, I have ladies and I have boys, so I have the whole kids, and these kids are all engineers. All right, next slide, please. The mission of the school is we gonna graduate high qualified civil engineer, prepare them for entry level position in civil engineering, and also for further, to go to graduate school, and also they can be the leadership, for the communities in Guam, Micronesia, and many other places. And when I go to sometimes, for example, in Ponape, you see some friends there, and they are running some, agencies, and that's our goal. We're gonna have a qualified engineer and all professional. Next slide, please. So I'm gonna give you, kind of the background. How do you start it? We start with 1985. We started on this, we call it the pre-engineering program. And the goal was to give them some courses to students, teach them some, and make them ready to be accepted in as a junior for the other university that is, and they back to Guam. So that was a pre-engineering program. But and then they to meet the current demand for engineers and also complete the university mission, and then the School of Engineering created. And they officially in 2016, Board of Regents opened officially a School of Engineering. But still, we didn't have any program yet. And then we put together established advisory council, and that was the biggest help. And that's I want to thank to all of the members and really appreciate of them because they give me the direction, what courses and many things, advice, and it's helping the student and provide the summer internship program for the students. And really, they are a big help, and they are still members. And we have a, I think we have to have a. We used to get 3 times a year, but I think it's a little bit delayed. We have to start it. So it really appreciate, and also thanks to WERI, and that was another. I have two big group. One is advisory council, and another one was WERI. And Joe Rouse really worked with us. We worked together. We put the courses, and it was, sorry for Joe, but really thanks to all the members. And then the Board of Regents approved our package for 4 years Bachelor in Science in Civil Engineering in the spring of 2019. And that was a lot of work. And then this program, the WASC approved the program. We had an interview with the WASC and they approved the program in June 2019. And starting was fall 2019. So now we have a school engineering. Next slide, please. Now at this time, the number of students, when we got after WASC approval, suddenly the number went up. At this time, we have 230 students in the program. I remember when we started pre-engineering, I remember I had 2 students in a class. If one of them failed, I had nobody. But now we have 230 students. And then some of these students, they are double major. It means they already had their bachelor in business or the other. Now they are getting 4 years for getting engineer. So there are a number of them is a double major. And then we have from these 230, we have students from FSM, we have GUAM, we have, it's all combination and it's really great. And they are top students. And we're gonna have graduate. It means they're gonna finish in spring of 21, 4 to 6, depends. It's gonna be graduating with a bachelor's degree. And in the fall of 2021, we have 12 engineer students. And is already the agency asking for them. Our job is already set. But these are top students, and I'm proud of each of these students. Okay, next slide, please. And then the challenge was, first of all, the biggest challenge was hiring engineering faculty. Hiring engineer is very difficult. Somebody with PhD and a PE license, to bring them from state or different place to GUAM, very hard. But we done it. We have 4 full-time engineer faculty, and also we have 4 part-time faculty. I will show the picture. And then we finish developing the curricula. We have to, students have to take 127, 28 course, and some of them is a GE, some of them core courses. And another one was attract a student to the program is ongoing, and the WASC accreditation is complete. And the next step is facility funding for building construction That's a little bit problem we have. And then laboratory structure, soil, and hydraulics. The laboratory is kind of hard is we have, but we need more equipment. Next slide, please. And these are our faculty. This is a Dr. Hung. He is a professional engineer, he structure. And then we have Dr. Patil, who's a geotechnical, take care of the, and also Dr. Patil is a unit chair of the School of Engineering. And we have Dr. Cheng or Dr. Jeffrey Cheng. He is a hydrologist and hydraulic. And we had one faculty, he left number 3 months ago. They had a baby, so we have to hire put a new faculty and structure. And Perna is the biggest, is the administrative officer. Really big help for me. Next slide. And these are part-time. I have Dr. Teimuri. He's a PE and he take care of the teaching structure stuff. And we have Mr. Dennis Bulakas, and he is a surveying. He's doing the engineering surveying. And Julian Rosario is teaching engineering graphics. And then we have Jordan Brown, and really good, nice to have Jordan. Jordan is teaching the construction management. And you know, one of the big topic is a hard topic is the construction management. But he is good. He is now working at the Navy, but also helping us, the students. Nice to have him. Okay, next slide, please. Okay, the biggest challenge that I have is ABET. And you know, the ABET is the non-profit organization, the credit board for engineer and technology this. And really, it's really big because they want to, the non-degree organization that credit engineer program that provides assure the university meets the quality standard of the professional that program, and really is the biggest thing. And that's our challenge. That's going to be the big challenge. And then the ABET require, okay, next slide, please. The require is, you know, they have to have a facility. It means we have to have a classrooms, offices, laboratories, equipment that adequate for supporting an outcome student. And actually, when they say like the students graduate from the program, then the ABET, they're gonna come and do the site visit. And at that time, they look at the performance of a student that is complete the study. And that's the thing, when we get the graduate students, a student gonna be graduating next semester, and they're gonna start working, then that's the time we're gonna ask for ABET. But we need to have facility prepared. Okay, next slide, please. So we need to have a graduate from the program. We need to have facility. Facility, it means we have to have offices and laboratory. And then we have the sufficient number of faculty that they can take all the curriculum. And then another one, education objective. We're gonna look at what is their objective. Are we providing or are we supporting the objectives of the program, mission, vision? And then they look at our curriculum and then what support we are getting. So I'm getting over time. Okay, next one, please. Next. Okay, so I want to thank you first to administrative and staff at university. Really, they are helpful. And then I'm going to appreciate from the Board of Regents. And it's great now we have Pete Diaz. He's one of the, you know, he used to be, he is one of the board member for Advisory Council, and also he's a Board of Regents. He can support more support. And the member of the our advisory council, and I want to appreciate from all our faculty, at the office, and also I'm going to appreciate for the people who supporting us, and also engineering students and SAMI, Society of American Military Engineer, really great, and also the whole community of Guam. Now, that make the dreams coming true. Next slide, please. I want to just show you the, okay, the AWWA, they give us a check. They check to the School of Engineering, and then contract what? Consulting, and it was great. He give a check to us, and then Dr. Safa, he put the money, he gave a check, 50,000, and also equipment. And Black Construction, boy, they were great. You know, they give us, I went there and any equipment, they had this even in a box. And they provide the transportation, you know, the big truck came and brought out the equipment. And also NCES, thanks, Hawaiian Rock, SAMI, uh, and also mobile gas station, 100,000, and really great. And Navy hasn't donated anything yet, not yet. Okay, next slide, please. And attracting a student, as I said, summer advisory council, they are all professional, the decision-making consultant from military, this, and this group is supporting our really big help, is a higher student. And then for summer, and also a scholarship and the training and SAMI. Next slide, please. Okay, and then he look at the scholarship. You know, I just make a this. You know, like a SAMI 14. You know, SAMI Guam Post 14 of student summer. The summer internship students that they are here in the second year, in year 2, is required to go for working as a summer internship. It means help them to work with some other engineer in the field, get experience, improve their communication, and also learn how to work in the field. And Brown and Calvert, and also NAVFAC, 10 students. And this is just a one record. There are many of them, more stuff. Okay, next slide. And I'm gonna say again, congratulations. We have students, they're gonna graduate from the program and they're gonna get a bachelor's degree. And okay, next slide, please. And if you have any question, you can contact Ferna, our administrative officer, and or you can call me, Dr. K. And everybody call me Dr. K. That's easy. Okay, next slide. And this is just a couple of students from the class. They came out and said, okay, let's take a picture. And really, I'm proud of each of them. And they are, at this time, we have 14 or 20, they are on a dean's list. It means the GPA is 3.8 and above. And then we have 10 on the president list. It means they are almost four GPA. And really, each of these students that I see this, and they are top. I mean, very good. And I'm happy that we have a talented student. And these are the students, they're gonna be a big help for community, for the Guam. And it's good. I want to, you know, when this when this virus goes away, I like to invite a couple of the senators, especially Senator Shelton. She was interested to see a student. So I'm going to invite them and to talk to this student and see how they are happy. We just need the support. What support we need? Community support and also financial for building. The building, everything is done, design complete. The site is this, groundbreaking happens, construction, who's gonna build this is already identified, but we need the money to start. And that's my goal. When we start the building, then we can call for ABIT to come here. Opening the ABIT, has many advantages. First of all, enrollment goes up, and then we're going to be a center for training for people who are going to take the PE exam and these things. And also, it's going to be open the door for people coming from everywhere, from China, Korea, they come to this. And we are now only a school of engineering in the Western Pacific. And this is the easier, Hawaii is too far. It's much easier for people in, all the neighbor island, FSM, everywhere to come to Guam. And we have lots of scholarship for the students. But we need for running the lab in these things, we need more, support. So as I said, I like to invite after this virus goes, invite all the senators to see the boys. These are the boys and the girls from.
Thank you,
And
Sharon.
thanks. Yeah, I appreciate.
For that update. And it's been great to see all the support that has come from across the whole community to launch the School of Engineering, and we're on a roll now.
Yeah.
I'd like to thank everybody who participated in the meetings, all 4 of them, and especially today. The members of our legislature, Board of Regents, Utilities Commission, our partners from GWA, Guam EPA, Captain Tim Libertor and his staff from NAVFAC Facilities Engineering Command, Marianas and JRM, our partners in AWWA and the School of Engineering, with whom we have a longstanding and productive relationship. So it's been great, and I want to thank Amanda and her team for facilitating this. It's been a real success, and I'm really pleased to have been able to be part of it. So I'd like to invite everybody to stay on for our encore presentation here of Mallory Duenas, who's going to be explaining the research that we're doing on PFAS contamination, which is, of course, of great interest to everybody in our water resources. So I'll hand the controls back over to Amanda to make that happen. Thank you again, everybody.
And Michelle, very good.
Hi, everybody. Before we go ahead and move on, because it's our final day, what we'd like to do is do a quick group photo. So before we move on to Mallory's, to the encore of Mallory's presentation, I'd like everybody to turn on their video, then we'll do just a couple of photos so we can kind of have like a meeting photo. I know that we all can't be there together. However, we definitely would like to have some memory to share with all of you for attending today. So if you can turn on your video, we'll do a quick picture before we move on to Mallory's presentation. Mallory is also on. We are going to be playing a recording of her presentation to ensure that everybody is able to hear her and to see the presentation. But she is still logged on and she'll be able to answer your questions, and I will share her email in the chat. But before we do that, please turn on your video. We're going to go ahead and take a couple of photos, okay?
Hey, happy day, everyone. I'll count the 1, 2, 3 as we do in a physical area. So please have your videos on. All right. Okay. 1, 2, 3. Please say cheese. Okay, so I'll be taking multiple photos as there's a lot. Thank you to our dignitaries who have joined us for today. 1, 2, 3, cheese. Okay, please stay smiling. We love WERI. Okay, just a few more. 1, 2, 3, cheese. Cheese, 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 cheese. Okay, and that concludes our group shot. Thank you, everyone.
Thanks, Michelle.
Thank you, everyone. So we're going to go ahead and turn it over to the presentation by Ms. Mallory Duenas. As I mentioned, she is logged on, so if you have any questions, you can share it in the chat. We will be playing a video recording of it to ensure that We don't have any technical difficulties. And I also will be sharing the recording with everybody at the end of the meeting as well. As a reminder, we will be sending out recordings of all of our meetings. We're just going to take a little time to edit it before we put it out. So by end of next week, we should have the meetings out for you to see on YouTube. In case you missed it, you weren't able to attend, we'll have those available. And with that said, I'm going to go ahead and share the presentation. Thank you so much to everyone for joining us. Thank you, the WERI team, for allowing Yojigli to support you in your great Let's restart. Yeah, for enough.
Hi everyone, I'm truly sorry for the audio and technical issues I was having during my presentation. I'd like to record my presentation and I will forward this to GLE as well as colleagues for putting on to a website and linking so everyone would be able to access it. Once again, thank you for your patience. My name is Mallory Nicole Duenas, and I will be presenting on behalf of Dr. Kim, my project advisor, and I'll be presenting the potentially impacted PFAS sites in Guam. PFAS are man-made perfluorinated compounds. Two compounds, PFOS and PFOA, are no longer produced in the US, but they can still be found in products coming from other countries. The unique amphiphilic properties they possess allow them to be both persistent and mobile in the environment. Past studies have showed PFAS to be both persistent and bioaccumulating agents in humans. Therefore, 6 common detected compounds are listed in the UCMR3 and are monitored by regulatory bodies. Results from a US EPA study found 6 of Guam's groundwater wells were contaminated with PFAS. In this presentation, I will focus on Hagatnian wells A23 and A25 as their concentrations exceeded US EPA's health advisory limit of 70 nanograms per liter. Potential contamination sources near A23 and A25 are suspected to be contributing to the elevated concentrations in these wells. Hydrogeological and literature research led to the selection of the following candidate sites shown here that were subjected to or impacted by a known source of PFAS. Potential use of aqueous firefighting foam may have occurred at an airplane crash site incident at Nimitz Hill. Events will collect in stormwater drainages or ponding basins. Additional attention is extended to Basin 1 as it is located downhill from a local fire station. A pump station along Trout River released millions of gallons of wastewater into the river until it was upgraded in 2006. Surface water flow from Trout River could transport the discharged wastewater to Agania Swamp, which was also an illegal dump site in the past. During our preliminary study, we collected 22 soil sediment 3 surface water, and 2 groundwater samples. Multiple samples were obtained from Chout River as waste had overflown from a sewage cover next to the river. For Agana Swamp, samples were taken from stormwater drainages as well as the Hagana River that runs through the swamp. Samples were shipped to University of Rhode Island for PFAS analysis. Out of 34 PFAS, 19 of them were detected above 0.01 microgram per kilogram. Of the 6 UCMR3s detected, PFNA had the highest concentration of 14.4 from Chout River, sample number 4. Other compounds detected in 95% of all the samples were GenX, or HFPODA, and 6,2-FS. Highest concentration of GenX was detected at 15.6 microgram per kilogram in sample number 2, while 6,2-FS was 16.1 microgram per kilogram in sample 6. Uphill from the wells, Ponding Basin 1, sample number 16, had the second highest total PFAS detection. PFOS and PFH excess were dominant in Basin 1 with 4.75 and 5.55 microgram per kilogram, respectively. GenX is a less persistent and bioaccumulating replacement for PFOA. FTS compounds are potential PFCA or carboxylate precursors that can degrade to PFOA. 6,2-FS is associated with aqueous firefighting foams and is one of the replacements for PFOS. From the water results, 18 out of PFAS were detected above 0.1 nanograms per liter. PFH excess was detected in all the samples, but 30% of overall detection came from Agana Swamp. Well A25 were reference samples, and they had the highest PFOS levels of 197 and 230 nanograms per liter. PFOS was also observed in Agana Swamp with 38.8 nanograms per liter. Based on US EPA MRLs, 4 out of 5 samples had 1 or 2 UCMR3s exceeding their MRL limit. PFOS in the well samples exceeded the 70 nanogram per liter advisory limit. Other compounds such as other compounds such as FHXSA and FBSA were detected as well. FHXSA was highest in well A25 with 79.6 and 83.3, and FBSA was highest in Agana Swamp with 44.9 nanograms per liter. Chout River was not collected. Water from Chout River was not collected because the river dried up, but samples were collected last year and sent to URI for PFAS analysis. FBSA is a potential PFS SA, or sulfonate precursor, and FHXSA, which is a component of aqueous firefighting foams, is another replacement compound for PFAS. Just a side note, USCPA MRLs are in microgram per kilogram, and our research will show parts per trillion or nanograms per liter. So 1 microgram per kilogram is equal to 1,000 nanograms per liter. URI's or significance of using an LCMS is its capability of testing sensitive concentrations in parts per trillion, which is pertinent to the analysis of contaminants in surface water. Therefore, we will be reporting in nanograms per liter or parts per trillion in my thesis. Based on the results, Chout River, Agania Swamp, and Ponding Basin 1 are potential contributors to contamination in wells A23 and A25. Apart from UCMR3 detections, Gen X and 62FS, which are PFOA or PFAS replacements, were dominant in 95% of soil sediment samples. Among the 18 PFAS detected in the water, PFAS and PFHXS were dominant in well A25 and Agania Swamp. 2 non-UCMR3s detected in the water were FHXSA and FBSA. The former is a component of aqueous firefighting foams, and the latter is a potential sulfonate precursor. Presence of non-UCMR3s will continue to be studied and researched. Additional research of the Hagania area is also needed, as minerals only reflect one cycle of the wet and dry seasons. PFAS research on Guam is still in its infant stage, and this project is part of phase 1 in identifying potential sources to wells A23 and A25. Before I conclude, this project is in association with GWA and University of Rhode Island. And Dr. Kim and I would like to extend our gratitude to our colleagues for helping us during this project. Thank you all very much. And once again, I'm truly sorry for this. Please feel free to write it in the chat section, and we will try and get those answers to you via email or during the discussion of this advisory council. Thank you once again, and have a great day.
Okay. Once again, that was a great presentation by Ms. Mallory Duenas. Ms. Mallory is currently on, so if you have any questions, you're more than welcome to share in the chat. She also included her email as well. We already have a question from Ms. Maria Lewis of NAFAC Marianas. This presentation, when is the report anticipated? You can either type that in the chat, Mallory, or you can answer as well. You got a couple of kudos as well in the chat.
Hi, this is to Miss Maria Lewis. Can you guys hear me?
We can hear you.
Okay. As far as a report is anticipated, I hopefully will be graduating next semester, so that would be that would at least be my thesis report. But for the WERI technical report, which I believe this will be transferred into, Dr. Kim, would you like to tune in on that?
Yeah, Mallory's going to graduate on May next year, so hopefully we may release the very technical report at the end of next year. But please feel free to contact us, then we can share our data.
Yes, thank you.
Thanks so much, Mallory and Dr. Kim. Are there any other questions or comments you'd like to share?
Yeah, I'd just like to invite everybody to Mallory's thesis defense when the time comes. You'll be able to get a detailed presentation then.
Well, hopefully we have our big building so we can fit an entire crowd.
Right.
Thanks, Dr. J.
You did, Mallory. Nice job.
Are there any other questions or comments before I hand it back to Dr. Jensen, and we can close up our last meeting actually. So,
Okay.
is there any
Well,
other
I'd like to
questions?
thank I'll thank everybody one more time for coming. Aaron Sutton had to drop off. I meant to let him have the last word as kind of the co-sponsor of this. We got an echo here in the background. We as I mentioned at the beginning, partnered up on the basis of the success that they had in sort of pioneering this, and we're all learning together on the technology. I think in the future, meetings are going to be taking advantage of this technology. Even when we meet in a room, we'll probably have people beaming in from the outside. So it's a different world already. But thanks again to everybody for their participation. It's great being able to see your faces, even if it's just postage stamp size on the screen. And one of these days we'll get together for a real live buffet here and do it right. Thanks again to Amanda and her team for pulling all this off for us. So, like I say, I never know how to say goodbye to these. You just sort of pull the plug in and say goodbye. Thanks for coming and being part of it, and thanks for being part of the team.
Once again, thank you everyone for joining us for our the 4-day meeting for the WERI Advisory Council. We will share an email that gives you the link to the presentation, and then we will also share contact information as well should you be interested. And so once again, thank you all for joining us, and have a great rest of your week. Viva WERI.
I guess I'll wait for her to pull the plug.